the concept of matrices. So in this chapter, we'll study different type of matrices, their properties, classification of matrices. Okay. So adjoint, inverse. Okay. So many applications of matrices. So let's start with the definition of a matrix. What is a matrix? It's actually a rectangular array of symbols or numbers. Rectangular array means, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the rectangular array of numbers. So be it real or complex. Okay. So it may be imaginary also, like 2 plus iota, 3 iota, 5, 6, 7, 8, or iota, 2 iota, 5 iota. Okay. So matrices is basically this array of symbols. Basically it contains real elements or it may contain imaginary elements also. These are the number of rows. You have already studied in determinants also. This is R1, R2 and R3, and these are the three columns C1 and C2 and C3. So the order of this matrix should be 3:3. Number of rows into number of columns. Okay. Let's say I delete this row. Now what is the order of this matrix? Tell me. How many rows? 2. How many columns? 3. So 2 into 3. So this is the order. So basically, if you have elements like A11, like m rows and n columns, A12, A13 up to A1n. Okay. Now A21, A22 up to A2n, and then AM1, AM2 up to AMN. So that means number of rows, as you can see, is m, and number of columns is n. So what is the order of this matrix? It's m into n. Okay. So order, this is known as order of a matrix. The order of a matrix is m into n. That means m, you can say number of rows, and n is actually number of columns. Okay. So m may be equal to n also. Okay. So we will discuss the type of matrices also. So m and n can be anything. Now these are the elements of matrix. These are the first row elements. These are the first column elements. These are the second row, second column elements. So it may be real or imaginary, as I have told you. So I can write the elements like this. Aij. These are the notations which are basically used by IIT also. Aij represents the element of a matrix where I lying between 1 to, tell me, I represents the number of row and j is the jth column. So number of rows 1 to m, and j can lie between 1 to n. So this symbol actually represents the element in the ith row and jth column. Okay. So Aij this represents, and I belongs to 1 to m obviously, and j belongs to 1 to m n. Okay. So this is the introduction of matrices ki, basically, and this is actually used in various cases. I will tell you later. Okay, what is the geometrical meaning of matrices and basically how we use it in statistics or data. Okay. Now let's start with the classification of matrices. There are certain type of matrices. So let's start with this. Okay. Acha, let's do one thing before starting the classification. For example, the order, basically total number of elements is basically 8 in a matrix. So what are the possible orders? Tell me. For example, 1 into 8, 8 into 1, 4 into 2. Obviously m and n are integer natural numbers. So these are the possible orders. Okay. Now let's see the classification. Type of matrices. First type is row matrix. What do you mean by row matrix? only one row is present. Okay? For example, 1, 2, 3. What is the order for this matrix? One row and three columns. So 1:3. Okay? Second is column matrix. Only column is present. 1, 2, 3. That means 3 into 1. Third, let's say null matrix of any order. That means all the elements should be 0. All elements must be 0. Any order, 0, 0, 0, 0. It is 2 by 2 null matrix or 0, 0. So different type of matrices, but null matrix means if all the elements of the matrix is 0, that means it's a null matrix. Okay? Rectangular matrix. What do you mean by rectangular matrix? If obviously M is not equal to N, that means it's a rectangular matrix. Okay? Fifth, if number of rows is not equal to number of columns. And the very important square matrix. We will study the properties of this type of matrix only, square matrix. Square matrix means number of rows is equal to number of columns. In our course, actually Mn is restricted to 3 only. We have already seen that. M and N are, we just study 1:1, 2:2 square matrices, and 3:3. That's it. Okay? So this is square matrix. If M is equal to N, then it is known as square matrix. Sixth is diagonal matrix. What is a diagonal matrix? Diagonal matrix is the matrix in which all the elements other than diagonal is 0. So this is, let's say, and it's a type of square matrix. Okay? Now what is known as diagonal? What is the principal diagonal? It is just, let's say, 5, 0, 0, 0, 6, 0, 0, 0, 7, for example. This is actually a diagonal matrix in which all the elements other than diagonal is 0, and this is known as principal diagonal. This is not the diagonal 0, 6, 0. Only this is the diagonal. 5, 6, 7 are the diagonal elements. Okay? And the sum of diagonal elements is known as trace. Sum of, we will discuss it later also, but sum of all diagonal elements is known as trace of a matrix. This is the word. And let's say this is matrix A. This is denoted by TRA. This is the notation. Okay? So trace of A means sum of diagonal elements. This is only the principal diagonal. This is the diagonal of the matrix, not this one. Okay? So 5 plus 6 plus 7. That means 18 is the trace of the matrix. Okay? So diagonal matrix is a type of square matrix. Rectangular matrix में there is no diagonal matrix. ठीक है? तो square matrix जो है, diagonal matrix is a type of square matrix. Seventh is scalar matrix. What is scalar matrix? Seventh is scalar matrix. Scalar matrix means all the diagonal elements are same other than 1, basically. Okay? Because in case of 1, we will call it a special case identity matrix. So this is, let's say, A, 0, 0, 0, 0, 0, and 0. This is a scalar matrix. It's a type of diagonal matrix. Diagonal matrix is a type of square matrix, and scalar matrix is a type of diagonal matrix. Basically, they are all square matrices. Okay, so scalar matrix. And the last one is identity matrix. This is a special case of scalar matrix. Identity is also a type of scalar matrix. So eighth is identity, in which A becomes 1. Identity or unit matrix. Okay? 1, 0, 0, 0, 1, 0, 0, 0, 1. These are all 3 by 3. These are all 3 by 3 matrices. You can make it 1 into 1 also, 2 into 2 also, 3 into 3. Like, let's say identity matrix of 2 by 2 is 1, 0, 0, diagonal. Okay? So identity matrix is, you can write like this also. Aij is equal to 1 if I is equal to j, and 0 if I is not equal to j. Here also, Aij is some element, let's say A, if I is equal to j and 0 if I is not equal to j. यहाँ भी ऐसे ही होगा, aij is some element and बाकी में rest they are 0. So identity is a type of scalar, scalar is a type of diagonal, diagonal is a type of square matrix. So basically diagonal, square, scalar, identity, they are all square matrices. Their orders is m is equal to n in these cases. Okay? Understood? Now let's write what's a trace. I've already told you that trace is actually sum of all the diagonal elements is known as trace of a matrix. Let's see some properties of trace. Should I delete it? Let's see the properties of a trace of a matrix. So as I've already told you, trace of a matrix A is sum of its diagonal elements. Now let's see the properties of trace. Tell me, trace of A plus B. Can you break it? Trace of A, trace of B. Are you sure? Trace of A plus B is equal to trace of A plus trace of B. Is it correct? Pakka. See, trace of A plus B means if you add two matrices, for example. Okay? So the diagonal elements in A and diagonal elements in B will also add. So trace of A plus B will become trace of A plus trace of B. I will discuss the addition, but still we can write some properties also. Trace of K times A is K times trace of A. Okay? So trace of A plus B or trace of A minus B is same as trace of A plus minus trace of B, and trace of K of A is equal to K times trace. There is no property for trace of AB. Okay? Trace A into trace B, this is not correct. Trace AB is not equal to trace A into trace B. वो गलत हो जाएगा. ठीक है? So basically these are the two properties which will help you in solving the questions. कि अगर आपको directly, if you want to find the trace of A plus B, then you can directly add trace A and trace B, or scalar will come out in this formula. So trace K is equal to K times trace A. ठीक है? Okay. So next is determinant of a matrix. You know how to find the determinant? Have you studied it? So determinant of a matrix. Okay? So there is a certain value which is related to the matrix. This is known as determinant of a matrix. For example, 2, 3, 5, 6. This is the matrix A, and now you have to find the determinant of A. So 12 minus 15 minus 3. First thing is, determinant of a matrix is possible only if matrix is a square matrix. There is no determinant in case of a rectangular matrix. Major 99% properties we will study about square matrices only. Okay? So determinant of a matrix, first thing is, it is only possible in case of a square matrix. Okay? Now, there are two terms which we have already studied maybe. Singular matrix. What is a singular matrix? Singular matrix is the matrix whose determinant is 0. This is singular. And the third one is non-singular matrix. Non-singular matrix is whose determinant is not 0. This is non-singular. These are the terms which are related to a determinant of a matrix. So first of all, it is related to only square matrices, because you can find the determinant only when the matrix is a square. And the second one, third one is singular and non-singular terms. Singular means A is 0 determinant, and non-singular means mod A. So determinant of A is not equal to 0. Okay? So these are the terms. Basically, this is the introduction of a matrix. These are the properties or classification of matrices. Okay? Okay, let's move on. Let's see some binary operations: addition, subtraction, multiplication of a matrix. Let's start with addition of two matrices or many matrices. Addition of matrices. Addition is possible if the order of all the matrices are same. First of all, if you want to add matrices, order should be same. Same. For example, let's say 3:2. You can add all 3/2 matrices. Okay? So if order is not same, you cannot add. Okay? Second, the formula for addition is just add first element, first row, first column to first row, first column of other matrix. It's very simple. 1, 2, 3, 4. If you want to add by 5, 6, 7, 8, you can directly add these first elements. Kitna aega? 6, 8, 10, 12. It's very simple. If you want to add two matrices, so just add all the same elements. Okay? Third, now addition of matrices is commutative. You know what is commutative is? A plus B is equal to B plus A. Okay? A plus B ko if you add or B plus A, the value, the matrix will come. It's the same matrix. Is it associative also? Associative. What do you mean by associative? A plus B plus C is same as A plus B plus C. Okay? So it does not matter basically. If A plus B, if bracket is, if you add B plus C first, then A, or if A plus B, then C. So it's one and the same thing. Fifth, if you add A and a negative of A, it becomes null matrix, not zero. It's a null matrix. Or sixth, it's a law of identity that say A plus null matrix is same as A. These are the basic properties, okay, which are studied in last sets also. So A plus minus A is null matrix and A plus null matrix is equal to A. So these are the properties of addition. This is a very simple addition. What about subtraction? Subtraction of two, matrices. Same funda. It is possible if order is same. And the same funda if 1, 2, 3, 4 and minus 5, 6, 7, 8. So answer is minus 4, minus 4, minus 4, minus 4. Okay? And definitely subtraction is not commutative. A minus B is not equal to B minus A. There is a problem in associativity also. A minus B plus C is not equal to A minus B plus C. This is same. Obviously, A minus of minus A will become 2A, or A minus A will become 0, and A minus 0 will become A. Okay. So this is very simple addition and subtraction of the matrices. Okay. Okay. So now let's move to equality of matrices. What do you mean by equality of matrices? Equal matrices. Equal matrices means if the matrix are equal, for example, x plus 1, y plus 2, z plus 3, and w plus 5 is equal to 1, 2, 3, 4. You can directly compare the respective elements. First row, first column must be equal to 1, tab equal ho payenge. Y plus 2 is equal to 2, z plus 3 is equal to 3, and w plus 5 is equal to 4. So very simple concept. X is 0, y is 0, z is 0, and w is minus 1. Okay? So equality of matrices may directly compare the respective elements. So you can easily compare the two matrices. If the matrices are equal, then the elements must be same. Okay? And there is no inequality in this. Okay? Understood? Now let's write multiplication of matrices. It's a very important part. Multiplication. Let's do first multiplication, then we will do some questions on it. Okay? Should I rub it? multiplication of, first of all, let's say 2 matrices we are doing it. There is a matrix A whose order is m into n, and there is a matrix B whose order is p into q. First of all, have you multiplied determinants? Have you learned it? To multiply these 2 matrices, A11, A12, A1n, A21, A2n, AM1 and AMN. Let's say A1P, ठीक है? 1Q, sorry, 11, P11, let's say, or let's say take B11, B11, B12, and then B1Q, B212, and BQ1 say P1, sorry. Okay? Now, if you want to multiply, there is a process of multiplication. A11 into B11, A12 into B21, and A1n. So basically, क्या same होना चाहिए? N must be equal to P. For example, N is 5. 5. Number of columns is 5. Number of rows must be equal to 5. तभी we can multiply the 2 matrices. ठीक है? Number of, first part is number of columns of the pre-multiplier, this pre-matrix A. ठीक है? Must be equal to number of rows of B, which is the post multiplication matrix. ठीक है? P into Q. So that means N must be equal to P. If N is equal to P, what is the order you are getting now? Final order you will get is, final order of AB you will get is M into Q, because number of rows remains same and number of columns remains same. ठीक है? So if you want to multiply 2 matrices, 2 square matrices, sorry, 2 matrices, ठीक है? So number of column of M into N and number of rows of B, M is to Q, must be same. That means N must be equal to P and final order must be M is to Q. ठीक है? So this is the method you will multiply the determinants also. ठीक है? So these are the 2 basic properties. Ki if you want to multiply these 2 matrices, so the number of columns basically must be equal to number of rows. तभी आप you can multiply. And the final order you will get, obviously the number of rows is M and number of columns is Q. So M is to Q you will get. ठीक है? Otherwise multiplication is not possible in matrices. These are the 2 basic things in multiplication. Now third is basically we will do some properties. Tell me, multiplication is commutative or not? No, it's not necessary. AB is not necessarily equal to BA. It may be equal to BA in some cases. ठीक है? जरूरी नहीं है. So AB is not equal to BA. May or may not situation है. So we can't say it's commutative always. ठीक है? Fourth, is it associative? It's very important. Third, fourth properties. Is it associative? ABC, let's say I take ABC, the multiplication of 3 matrices. How will you do it? कैसे करोगे? किसको पहले multiply करोगे? किसी को भी कर सकते हैं. It's associative. If you multiply A and B, then after C, then C is same as A is the pre-multiplier and B, C. It's associative. And it is valid for any number of matrices multiplication. Basically. For example, let's say take an example. A, B, C, D, E. Let's say I want to multiply first AB, CD, and E. Then AB, let's say it's Q, CD is P and E. Then QP, and then E. So this R and E. Finally, you're getting some matrix. If you do A, B, C, D, E, let's say BC and DE, you'll get the same matrix. So it's associative. Okay, and it's a very, very important property because we will use in this property in our questions. So it's very important. Okay, so please note down. It is associative, and it hardly matters what is the type of matrix and how many matrices we have taken. Okay, you can take infinite matrices and you can club any of them. Okay, so for example, we write A. Let's say for example, AB is equal to BA. Let's say. So A, B, A, B, A, B. So you can write BA as AB. Okay? इस तरीके से BA, for example. So you can interchange. We will do some questions on this, but this is the funda basically. So you can put anything and you can multiply any two matrices. Okay? It's associative. Okay? Now, fifth property is, should I rub it? What about a distributive property? Distributive is A into B plus C is equal to AB plus AC. Okay? See, the order matters. AB is not equal to BA. Okay? You cannot write AB or BA or CA. It's wrong because AB is not equal to BA. Okay? So AB plus AC or minus. So AB plus minus AC is equal to that same AB plus minus AC. Okay? This is known as distributive law. If you multiply a matrix with a null matrix, what will you get? Obviously, null matrix. It's a very simple property. Okay? If you multiply any matrix with a null matrix of the order, so you will get a. But these multiplication is actually happening because because condition we are satisfying m is equal to n is equal to p, है ना? तभी ऐसा हो सकता है, नहीं तो it's not possible. Now the important part, seventh, it's also very important. What if the product of two matrices is a null matrix? Tell me, what about A and B? JEE Mains has also asked this question, I think in 2012, I guess 11 or 12, I don't remember exactly, on this property. If AB is equal to 0, what do you have to say about A and B matrices? क्या होगा बताओ? A and B, can they be a null matrix? Or is it possible without being the A and B are not null matrices? So what are the conditions you can get? First is either A is 0, null matrix, and B is non-zero. For example, this is the first case. Okay? Second case, A not equal to null matrix, but B is equal to null matrix. You will get AB is equal to 0. Third case, either both are 0. Is there any case left? This case, if A is not a null matrix and B is not a null matrix, is it possible the product is a null matrix? Achha, take any example where A is not a null matrix, B is not a null matrix, and AB is still a null matrix. Take any example. बनाओ अपने आप. Tell me. Take an example where A is not a null matrix, B is not a null matrix, but still AB is a null matrix. And I am saying it is possible. If any two rows or columns are same, take it. सब लेके देखो. Let's say A is 1 0 0 0. ठीक है? and B is 0 0 0 2. Am I correct? सही है? 0 0 0 2 0 0 0 0 0 0 0 0 है ना? तो A B are not null matrices, but still their product is null matrix. Now, what is the condition actually? ठीक है? Condition क्या होगी if they both are not null matrices, but what is the condition? Condition is, first of all, write the condition. A and B are, सबसे पहले, they are square. They have to be square matrices. Without it, it's not possible. If you take two rectangular matrices and multiply them, okay. AB must be square matrices if they are not null matrices. So first condition is they are not square matrices. Second, A and B should be singular. That means determinant of A must be 0, determinant of B must be 0. तभी ये हो सकता है, नहीं तो it's not possible. See, determinant is, ठीक है? So if A is it's not a null matrix, B is not a null matrix, then obviously A and B determinant must be equal to 0. If you want AB is equal to 0. ऐसा नहीं है कि determinant भी 0 नहीं है. A 0 nahi hai, B it's not a null matrix, they're not null matrices, determinant is also not 0, so it's not possible ki null matrix aa jaye dono ka. 2 by 3 2 by 3 2 by 3 2 ठीक है. अच्छा, basically I just want, हाँ, just I want to tell the case if A is not 0, B is not 0, that means हाँ, basically हाँ, this statement maybe it's not correct. So, but A B has to be 0 if they are square matrices. ठीक है? मतलब if you are taking square matrices and you are multiplying them, then definitely you will getting 0 0 0, but they has to be singular. Without singular matrices, you will not get A B is equal to 0. That's what I want to tell. ठीक है? To correct it, if A and B are square matrices, then AB should be singular. ठीक है? चलो. Written? Please write it. This is a very important property. If AB ka product is a null matrix, then either A is 0, B is 0, or both are 0. But the fourth case is very important. If A is not equal to 0, B is not equal to 0, then also you can get the null matrix. But if they are square matrices, then they have to be singular. And as ma'am said, if they are not square matrices, it may be 0.
Let may be 0, and the matrices are not 0. But if they talk in terms of
Determinant, yeah.
Then they have to be square because determinant is defined
only if a square matrix is known.
And you will apply the condition determinant of AB is determinant A to determinant.
That I will tell. ठीक है?
That they have done in determinant.
Yeah, definitely. ठीक है? So let's move on. आगे. Eighth property. Eighth property is if AB is equal to AC. Now tell me, what is the condition for A and B and C? बताओ. That means A into B minus C is a null matrix. And the same thing, there are some conditions. If A is 0 and B is not equal to C, A is not equal to 0 and B and C are equal matrices. Either both of them, A is also 0 and B is equal to C. And last, same. If A is not equal to 0, B is not equal to C, then also it's the product can be 0. So if there is square matrices, then determinant A is 0 and determinant of B minus C must be 0. If there is square matrix, if the determinant is possible, then you can take A0, B0. Otherwise, it's also possible in rectangular matrix also. ठीक है? So determinant is 0. Basically, I want to tell this property because there are some certain questions based on these properties in which the product is 0 and they are not null matrices. So you have to apply this funda. Mod A, determinant A is 0 and determinant B minus C is also 0 if they are square matrices. Okay? These are very important properties, basically starting from 7th property. Very important. Now 9th. Ninth property is actually the binomial expansions, algebraic expansions, a plus b whole square. What is a plus b whole square? In case of matrix, you will not write a square plus b square plus 2ab. Okay? You will write this like this: a plus b into a plus b, and you will multiply like this: a into a plus a into b, because order is very important. A b b a. Now next, ba plus b into b. So a into a you can write a square ab ba plus b square. You can write all the formulas of a plus b ka whole cube or any formula like this. If ab is equal to ba, then you can write a square plus b square plus 2ab. If ab is equal to b, if ab is equal to ba, then actually you can write ki a plus b ka whole square is equal to a square plus b square plus 2ab. Okay? This is a very important thing. You can't open, you can write the algebraic entity like you have studied earlier also. In case of matrices, you have to take the order. Okay? So you have to keep in mind कि इस तरीके से करना है आपको. 10th. Obviously, I've already told you a into a up to n times. You will get a's to the power n. If you multiply the same matrix n times, you will get a's to the power n. Okay? Now, what about if I take determinant of this? A into a का determinant. सबसे पहले तो they are all square matrices, because without square matrices the determinant is not possible, because the order must be same of a, and you are taking the determinant. That means, yeah, so you can write mod a determinant a into determinant a into determinant a up to determinant of a. That means it's a very important property. A की power n का determinant is equal to determinant a's to the power n. Okay? If you multiply the same determinant n times, you will get a's to the power n, and the determinant of a's to the power n is equal to determinant of a wholes to the power n. Okay? So if you find any question where you have written, let's say, a's to the power 5 is equal to 32, so you can write determinant a is equal to, because the same property, because you can write a's to the power 5 is equal to 32. Okay? So please remember this property. So A is obviously a square matrix, because the determinant, you have to take the determinant. So these are all square matrices because they are all same. So order, obviously they have to be same. N must be equal to P, but because we have to find the determinant, that's why N, P, they're all square matrices. So A is to the power n ka determinant is determinant ki power n. Okay? 12th, the similar property. Similar property, AB का determinant is equal to, पहली बात तो AB obviously जब भी multiply होंगे जब n number of columns is equal to number of rows, but this is equal to mod A, determinant A, determinant B, if A and B are square matrices. See, if its order is 2 by 2, its order is 2 by 2, they can easily multiply it, and determinant is determinant A, determinant B. So 2 is to 2, 2 is to 2. You can take the determinant. If the matrix is rectangular, you cannot break it like this. Mod A, determinant A into determinant B is not equal to A, B ka determinant. if they are square matrices, because determinant is not possible in case of rectangular matrices. ध्यान रखना इस चीज को, ठीक है? मतलब it is valid for any number of A, B, C, D. If they're all square matrices, that means determinant A, determinant B, determinant C, determinant D. ठीक है? And I guess last is KA determinant. Let's say A is a square matrix of order n. Obviously मैं determinant की जो भी बातें कर रहा हूँ, I'm talking about determinant. That means obviously I'm talking about square matrices only, ठीक है ना? So A is a square matrix of order n. What is the formula? What is the value will come out? If you multiply K with a matrix, सबसे पहले if you multiply K with a matrix, the definitely that K will multiply to all the elements. For example, determinant A is actually 1, 2, 3, 4, and if you say what is KA, then it is K, 2K, 3K, and 4K. If you take the determinant of this thing, definitely K square will come out. That means if the order is 2 by 2, then K ki power 2 will come out. If the order is n into n, the K ki power n will come out, because K is multiplied to all the n rows and n columns. So K ki power n will come out. You have studied the properties of determinants. Okay, if you want to take column, you have to take the whole K from all, either one row or one column. So K square. So basically the answer is, if A is a matrix of order n, answer is K ki power n, determinant of. Okay? So this is a very important property. Well, after 7th, it's very important. 7th, 8th, 9th, 10th, 11th, 12th, 13th. These are very important. Okay? Now let's do some questions based on multiplication, addition, transpose. Sorry, I have not discussed transpose. Let's discuss transpose also. Then we'll do some questions. Okay? And based on classification, equality. First try this, then we will discuss transpose of a matrix, and then we will do some questions based on all these things we have studied till now. Understood? आ रहा है समझ में? हो गया? Transpose, write the heading, transpose of a matrix. What is a transpose? If you interchange rows and columns, you will get a transpose of a matrix. If you interchange A, B, C, D, E, F, G, H, I, transpose, either you write AT or A dash. You'll get, if you interchange rows into columns, A, B, C, D, E, F, and G, H, I. This is the transpose of a matrix. Okay? So there are some properties related to transpose. I guess you have already studied in 12th class. First is A plus B transpose is A transpose plus B transpose. Simple. Transpose, the transpose of a transpose is A. K times K8 transpose is K into A transpose. And the most important one, AB. We easily remember this property because this is a special one. AB transpose is equal to B transpose A transpose. Okay? And it can be applied for many matrices. A, B, C, D transpose is equal to D transpose, C transpose, B transpose, A transpose. Let's do some questions on based on all these things we have studied now. Okay? Let's start. Somebody has written. Okay. So now let's do some questions. Then we will start symmetric and skew symmetric matrices, because we have to do today we have to do till square matrices, skew and symmetric matrices. So let's start with some questions. Write down. First question is, if A matrix is A, B, C, D, B matrix is P, Q, where this is not equal to 0, 0, obviously, null matrix nahi hai. AB is equal to B and A plus D is equal to 2. Find the value of AD minus BC. A is ABCD, 2 is to 2 matrix. B is 2 is to 1 matrix. This is not a null matrix. AB is equal to B, it's given. Also, it's given A plus D is equal to 2. So find the value of AD minus BC. Okay. Done. First, find out the matrix multiplication AB. Hai. First, find out AB, then find out B, and then apply the principle of equality of matrices. Okay. Then A plus D is also given, it's equal to 2. P is not equal to 0, Q is not equal to 0. So find the value AD minus BC. So it's coming out to be what is AB by the way? वैसे AB is AP plus BQ, है ना? Solve it, solve it. AP plus BQ, and what is B? CP plus DQ, and this is equal to B. B is, that means AP plus BQ is equal to P. This is the first equation, and CP plus DQ is equal to Q. Second equation. Third equation is A plus D is equal to 2. Find out. वैसे तो it's very simple question. If you have studied inverse, you can easily do it. If you have studied inverse. Just compare ना. You can find P by Q from here. P by Q निकल सकता है ना यहाँ से. क्या आएगा? BQ is equal to what? P into 1 minus A. So what is P by Q? B upon 1 minus A. है ना? यहाँ से भी आ जाएगा. क्या आएगा? CP is equal to Q into 1 minus D. And what is P by Q? Tell me. P by Q is 1 minus D by C. Just compare it. हो गया. So when you will compare P by Q, so you will get B upon 1 minus A is equal to 1 minus D upon C. BC is equal to 1 minus A plus D plus AD. So AD minus BC is A plus D minus 1. So answer is 1. Simple.
Assuming that Q is non-zero. But here when we say that PQ is non-zero, that it's not necessary that P and Q are both non-zero. When we're dividing by Q, we are assuming that Q is non-zero. But when we say that the vector P is non-zero, the matrix P, one of P or Q can be zero. It's not 0, 0.
But it's given.
It's given that both are non-zero. So वहाँ पे फिर हम ये नहीं लिखेंगे ना.
क्या?
It's not the zero. We write P, Q non-zero, P non-zero and Q non-zero. Question में जरा सा change.
I think it's same. P is non-zero, Q is non-zero. It means P is non-zero and Q is non-zero, both.
When we see the matrix P is non-zero, then one of the components can be zero. इस तरीके से लिखते हैं. But when we say the matrix is non-null, then one of the elements can be.
नहीं, I think it means कि both the elements is non-zero. Both. P is also non-zero, Q is also. And this means this only. Because we can compare na easily. So P is non-zero, Q is non-zero. Both are non-zero. ठीक है? So have you studied the concept of inverse also वैसे by the way? हाँ जी. B into A minus 1, A minus I होगा. It's not 1. If you take common, अच्छा एक चीज और, if AB is equal to B, if AB minus B is 0, so if you take B common, वैसे तो common आएगा नहीं because we can write like this also. Yeah, A minus I into B, not 1. ठीक है ना? 1 नहीं आएगा. If you are subtracting, if you are taking common B, so you have to write not 1, you have to write I. मैट्रिक्स में से 1 नहीं सब्ट्रैक्ट हो सकता. मैट्रिक्स ऐसे मैट्रिक्स ही हो सकता है. वैसे you can do like this also. If you post multiply with B inverse, so you will get A is equal to I. That means A and D are 1 and 1. तो AD minus BC is 1. वहां से डायरेक्टली आ सकता है. अच्छा, ओके ओके ओके, सॉरी सॉरी सॉरी. ठीक है ठीक है. आई थॉट लाइक दैट. ठीक है ठीक है. तो दिस इज द ओनली वे. ठीक है. ठीक है. So let's do another problem. Second problem. Second is right. If A is A B C D, sorry, PQ 0 1. Now show that is to the power 8 is p is to the power 8 0 1, p is to the power 8 minus 1 q upon p minus 1. It's a very simple problem. Multiplication. A is to the power 8 को prove करना है. If a is p q 0 1, a is to the power 8 is p की power 8 0 1 and p is to the power 8 minus 1 into q upon p minus 1. Find a pattern basically, है ना? क्योंकि a is to the power 8 के लिए find a pattern first. A square, a की power 4 इस तरीके से. You'll get a pattern, or a cube. In these type of questions, you have to find a pattern of a square, then a cube. So you'll get to know what is a to the power 8. It will follow a certain patterns. First, find out a square, okay? Then a cube. So you'll get to know what the pattern is, and based on that, you can actually say कि ये आएगा. Done. So what is a square? PQ01 PQ01. So what you will get? P square. ठीक है? Then PQ plus Q. Then 0. Then ठीक है? Let's do one more time. PQ01. Then what will you get? PQ. देख रहे हो? So if in a square you are getting p square 0 1 and p plus 1 into q. In a cube you will get p cube, then q plus pq plus p square q 0 and 1. A4 you will get p4 q plus pq plus p square q plus p cube q. That means similarly in A8 you will get what? P is to the power 8 0 1 q plus pq plus p square q up to p7q. And this is a GP. GP का formula q आप common ले लोगे. So take q common. And answer is 1 plus p up to p की power 7. What is the formula? 1 minus r की power n total number of terms upon 1 minus r. Provided no p is not equal to 1. ठीक है? So this is the formula. So a is to the power 8 is p8. This is the formula for this. ठीक है? If p is 1, then obviously it will become 8. 8q. है ना? नहीं, P is 1 means all the 8Q ना. If P is 1, formula for a GP is same, is different. If P is not equal to 1, if R is not equal to 1 basically. So if R is equal to 1, all the terms become same. The formula is N into A. Okay? Let's write another question. Understood? So in these type of problems, actually you have to do, you have to follow the pattern basically what is showing. Okay? Right. If A, determinant of A is not equal to 0, A is a matrix. Determinant A is not equal to 0, and AB minus BA is equal to A. Now prove that determinant of B plus I is equal to determinant of B minus I. I is the identity matrix. Determinant of A is non-zero. That means A is a square matrix whose determinant is non-zero. So AB is happening. That means B is also square. So AB minus BA is equal to A. Prove that B plus I determinant, I is the same identity matrix of the same order of B, and B minus I. Both determinants are same. You have to prove it. So AB is a square, are square matrices of same order. Because I have entered, it's written, because determinant A is non-zero. That means A का determinant तभी non-zero होगा तभी when obviously A is a square matrix. So A is a square matrix, and if AB is there, that means B is also a square matrix of same order. So, and I is also the same square matrix of same order of B. You have to use this condition: AB minus BA is equal to A. हुआ? हाँ. इसको उधर भी जा सकते हो, BA plus A. So take determinant both the sides, है ना? हाँ. डिटरमिनेंट भी लेना पड़ेगा ना दोनों तरफ, बिकॉज मैंने डिटरमिनेंट के लिए बोला है. यू आर डूइंग राइट. देखो थोड़ा सा बस हल्का सा मिस्टेक. इफ AB इज इक्वल टू A प्लस BA, यही है ना? सो AB इज इक्वल टू A इंटू क्या आएगा? I plus B into. If you take determinant both the sides, you can write A into B, because A and B are square matrices of same order. अब because A is non-zero, that means determinant B must be equal to I plus B. ठीक है? Now the second step. अब A को उधर ले जाते हैं. AB minus A is equal to BA. A कॉमन क्या आएगा? B minus I is equal to BA. Taking determinant on both the sides, you can break it because they are the same square matrix of same order. Same thing, you can cancel out A because A is not equal to 0. Determinant हो गया proof. Determinant भी लेना था साथ में, ठीक है ना? Because determinant proof करना है, we have हमें ये proof नहीं करना कि B plus I is not equal to B minus I, ठीक है ना? We have to take the determinant. So first AB is equal to A plus BA. Take determinant both the sides. Then break it because they are square matrices of same order. Then B का determinant is equal to I plus B. Then same यहाँ भी वही, इसको A को इधर ले जाओगे तो A B minus I is BA. Take determinant both the sides. A will cancel out because A is not equal to 0. It's given. So that's why B plus I determinant is equal to B minus I determinant. Understood? Let's do one more like this. Right. If M is a 3 by 3 matrix, if M is a 3 by 3 matrix, determinant of M is equal to 1. Determinant of M is equal to 1. M into M transpose is equal to identity matrix. M into M transpose is equal to identity matrix. Prove that determinant of M minus I is equal to 0. Same कुछ उसी तरीके का है almost. If M is a 3 by 3 matrix where the determinant of M is equal to 1, also given MM dash is equal to I. That means if you multiply M and its transpose, you will get I, identity matrix. You have to prove that M minus I का determinant is equal to 0. Done. You can't write A determinant minus B determinant is equal to A minus B determinant. ये गलत है. There is no such property. Determinant of A minus determinant of B is equal to determinant of A minus B. ऐसा कुछ नहीं होता. It's wrong. And you can't take the special case also. Don't take M is equal to I, that's why it's 0. Prove it. Acha, hint is you can substitute I as mm dash. This is the hint. Acha. Now start. Put I is equal to mm dash. Now take m common and so on. Do it. This is the hint. This is the first step you can do. हो गया देखो क्यों तो सिमेट्रिक होता है ना m अगर स्क्वायर में दैट डजंट मीन कि वो सिमेट्रिक भी है सिमेट्रिक में तो mm डैश बराबर होंगे चलो लेट्स स्टार्ट लेट्स से वैल्यू इज फॉर एग्जांपल a जिसको हमें चाहिए 0 है ना you want this a is equal to 0 a चाहिए ना डिटरमिनेंट दैट्स द वैल्यू इज a अच्छा I have told you to put I as m dash m common obviously first step क्या मिलेगा I minus m dash square matrices both so you can break it so m and I minus m dash this is obviously 1 this is 1 can you write I as I dash what is the property I minus m dash this is correct a dash plus b dash is a plus b ka dash a dash minus b dash is a minus b whole dash determinant of transpose and determinant is same a dash ka determinant is same as determinant of a can I write the determinant of I minus m now this is correct you cannot write m dash is equal to m because the matrix is not symmetric so you have to take I dash then I minus m whole dash and determinant of matrix is same as determinant I minus m now can I write minus 1 into m minus I it's a square matrix of 3 by 3 order what is ka this is a scalar matrix ka that means minus 1 into m minus I ka determinant which is equal to what minus a this is minus a so if a is equal to minus a that means a is 0 this is the proof so it has checked all the basically major properties first of all you have to put I is equal to mm dash then take out common then first property in this question was key break it m into I dash minus m sorry I minus m dash then m is 1 and I dash minus m dash you can write I is equal to I dash also then second property of transpose this question I've checked I minus m ka dash then third property ki transpose ka determinant is equal to the same determinant then fourth property minus 1 into m minus I वो k की पावर a वाली property minus 1 का की power what cube it's minus 2a is equal to 4 properties question actually combined of 4 properties ठीक है so you cannot write m is equal to m dash because it's not symmetric but you can write I is equal to I dash identity matrix is a symmetric matrix understood ठीक है write it, then I will give you the next question. हाँ, in objective questions you can take the special case. Objective questions में अगर पूछा गया है m minus I का determinant, तो you can take I. m को I मान लो, तो I into I is I, तो 0 आएगा आंसर. Objective में it's very simple, है ना? You can take special case and mark the answer. Let's do one more question. हो गया? पक्का सबका? चलो, I will write it here. Let A, B, C, D, I'm writing here. Let A, B, C, D be real matrices. Real matrices means the entries are real. The elements of the matrices are real. And they are not necessarily square matrices. देख लो. Not necessarily square. कोई जरूरी नहीं है square है. Now, the first condition is A dash transpose of A is BCD. B dash is CDA. C dash is DAB. And D dash is ABC. Okay? So A dash is BCD, transpose of A is equal to BCD. B dash is CDA, C dash is DAB, D dash is ABC. This is given. Now, if S is a matrix which is the multiplication on this order, A, B, C, D. If S is a matrix which is equal to A, B, C, D in this order, prove that, लिख लीजिए, S cube is equal to S. S cube. Prove that S cube is equal to S. Yani ABCD whole cube is equal to ABCD by using these four properties, four relationships. Do it. It's the question based on the properties of transpose as well as associativity of matrices, multiplication of matrices. It is containing these two properties. SCA. Prove S is equal to S dash. बहुत close हो. You're right, S dash आएगा, but you have to prove now S dash is S. कौन सा क्वेश्चन नंबर 4? हाँ. नंबर्स तो लिख ही नहीं रहा यहाँ पर कुछ. हाँ, उनके अकॉर्डिंग में भी क्वेश्चन नंबर इनसे पूछ लो, उनके पास होगा. Which question number is this? 5th. So I think इससे पहले पूछ लो, एक बार कंफर्म कर लो. मे बी इससे पहले वाला ही होगा शायद, बिकॉज हाँ वही पिछला क्वेश्चन आई थिंक. दोबारा एक्सप्लेन करना है. ठीक है, मैं कर देता हूँ. आप लोग करो, मैं दूसरा क्वेश्चन. See the problem, the last problem was M का mod is 1. M is a 3 by 3 matrix. M dash यानी transpose and this matrix is equal to I. You have to prove that कि M minus I का determinant is a null, is equal to 0. So what we have done is कि we have taken A is equal to M minus I. मतलब we have to prove A is equal to 0. ठीक है? Now A is equal to, you can write I as M into M dash because it's given. So substituting I की value in M into M dash. Now taking common M, you can write I minus M dash. Now because M is a square matrix of 3 by 3, so I minus M dash is also a matrix of 3 by 3. You can break it. Determinant of M by using this property, कि determinant of AB is equal to determinant of A into determinant of B. So I have already break it this like this. Mod M bar and I dash I minus M dash. So mod M is equal to 1. It's given mod M is equal to 1. So mod M is equal to 1. Now what about I minus M dash ka determinant? So it's, you can write I ko I dash minus M dash, because obviously I is equal to I dash. So you can write I is equal to I dash minus M dash. You can write I minus M whole dash ka determinant, because as you know the property A minus B transpose is A transpose minus B transpose. So you can write I dash minus M dash is I minus M whole dash. And as you also know कि A dash का determinant is equal to A का determinant. So you can write I minus M determinant. Now I minus M determinant को you can write minus into M minus I का determinant. And minus of M minus I determinant, that means this is K into A. So you can write minus 1 की power N, this is K, and determinant of M minus I. So N is actually 3. So this is minus of M minus I. And you have started with this only, M minus I. So this is same as minus A. So if A is equal to minus A, that means A is 0. Determinant से करना ही क्या है? नहीं, determinant से बराबर नहीं है. If determinant of A is equal to determinant of B, that doesn't mean कि A और B बराबर होंगे, है ना? अगर determinant of A और determinant of B अगर equal हैं, that doesn't mean कि matrix are also same. इससे कोई जरूरी नहीं है. Determinant का तो इसमें कोई use ही नहीं है. इसमें सिर्फ multiplication and transpose properties. हो गया? नहीं हुआ proof? S dash is equal to S नहीं हो रहा? अच्छा S dash क्या आया? नहीं, S dash वैसे क्या आएगा? D dash, C dash, B dash, A dash. एक काम करो, D dash को छोड़ दो और वो जो C dash, B dash, A dash है उसे ABC का ट्रांसपोज लिख लो. ABC का ट्रांसपोज किसके बराबर हो जाएगा? D. तो D dash D के बराबर हो गया वो. अभी बताता हूँ. I think somebody is writing ये वाला क्वेश्चन. होगा क्लियर? आप पूछ लीजिए. So A, B, C, D are real matrices, not necessarily square matrices. A dash is equal to B, C, D, B dash is this, C dash, D dash, S दिया हुआ A, B, C, D. you have to prove s cube is equal to s. चलो let's start with s cube. ठीक है, s cube is a b c d and a b c d. कौन कौन से आप साथ लेना चाहते हो? let's take abc together, let's take dab together. मैंने बोला था आपको, बताई थी प्रॉपर्टी शुरू में कि they are associative. आप कोई भी कितने भी ले सकते हो साथ में. You can take cda together and bcd together. What is abc? D dash. Very good. What is dab? C dash. What is cda? What is bcd? ठीक है. Now what I'm saying is, ठीक है, you have written obviously abcd का transpose and this is equal to s dash, but you have to prove s cube is equal to s. Let's not go into this. Take any three. What is this? Bolo. ABC dash. Very good. What is ABC dash? D. D dash D. This is S cube. Understood? ठीक है? D dash D is S cube. Now, इसको किसके बराबर प्रूव करना है? S. S is A B C D. What is ABC? Hence proved. ठीक है? ये करना था इसमें. S. हाँ हाँ, तभी मैम डी आया ना वो. ABC का डैश इज डी. डी डैश का डैश हो गया ना. ठीक है. सो दिस इज द प्रूफ. इफ S cube is equal to S. ठीक है. देखो यहां पे बस थोड़ा सा कैच था. इसको इसकी तरह लिखने के मतलब अलावा ABCD होल डैश इज इक्वल टू S डैश. इट्स बेटर कि आप C डैश B डैश A डैश को एक साथ किसी को भी ले, यू कैन टेक एनीथिंग, यहां से भी ले सकते हो. अगर आप इनको लेते तो क्या बनता? BCD का डैश. BCD का डैश इज A, सो A इंटू A डैश. और यहां पे करने के लिए आप BCD को अलग ले लेते, तो BCD को अलग ले लेते तो फिर ऑब्वियसली A इंटू A डैश ही आ जाता. You can take any three. मतलब यहाँ पे यही कैच है कि you have to take any three and then make it ABC का dash and then put and then same you can take any three in S also. It will prove. So basically S is equal to S dash भी prove हो गया. Symmetric basically. देखो. Next question is, so next two questions are of same type. Let P and Q be two 3x3 matrices. I think this is the question which have been asked, I think, in JEE mains or AIEEE in 2012 or 11. With 3x3 matrices with P not equal to Q. ठीक है. If P cube is equal to Q cube and P square Q is equal to Q square P, find the determinant of P square plus Q square. So this was a question, I think, which have been asked in JEE mains or I think AIEEE 2012 maybe. So PQ are 3x3 square matrices, and with P is not equal to Q, they are not equal. P cube is equal to Q cube and P square Q is equal to Q square P. These are the two conditions. So by using these two conditions, you have to find the value of P square plus Q square का determinant. Yeah, do you have any query?
Sir, can you explain that third question once again?
Which is the question? Can you repeat the question?
If determinant of A is equals to 0,
Hmm.
A into B minus B is
अच्छा,
equals to A.
ठीक
And
है.
prove B plus I is equals to B minus I.
Okay. See, देखना ना यहाँ पे. Determinant A is not equal to 0 as well as AB minus BA is equal to A, where A and B are square matrices of same order. This was given and you have to prove B I determinant is equal to B minus I determinant. So our first step is, solution is, if you take AB is equal to A plus BA from this equation, so AB is equal to, you can take A common, or you can take I plus B into A like this. Because if you open the brackets, it will get IA. You can write A as IA. So IA plus BA. Now take determinant of the sides. Determinant of AB is equal to determinant, because I have to prove determinant. This. So I have to take determinant both the sides. So this is I plus B determinant into determinant of A. Because A and I plus B are the square matrices of same order. That's why if I've taken the whole determinant, both the sides, that means it will break into two parts, I plus B into determinant of A. This also will break. Mod A determinant of A determinant B is equal to I plus B determinant into A determinant. Okay? So A will cancel out because A is not equal to 0. So obviously A can cancel out. So determinant B is equal to I plus B. This is the first thing we have proved, first part. If you have taken AB is equal to A plus BA, so take A common, I plus B, then taking determinant both the sides, AB is equal to this determinant, then break into two parts, mod A, determinant A into determinant B, because they are of the same order square matrices, then I plus B into A. So A will cancel out because A is not equal to 0. That's why B will become equal to I plus B ka determinant. Now same, doing the same process once more for this part. You know AB minus A is also equal to BA from here only, from here. AB minus A is equal to BA. Doing the same thing, I have taken A common. So you will get B minus I. See, AB minus AI. You can write A as AI is equal to BA. Now again taking the determinant on both the sides. So determinant A, determinant, you can break easily. Determinant of B, determinant of A, because they are square matrices of same order. Cancel out A because A is not equal to 0. So hence proved. Determinant B is determinant B minus I ka this. This is the second thing. Equating first and second, you will get the answer, required answer. So first you have to take A this side and then B at that side. So there are the two equations. So one will prove B is equal to I plus B ka determinant, and second will prove same B is equal to B minus I ka determinant. So दोनों prove हो जाएंगे. So by 1 and 2 you can say B plus I is equal to B minus I ka determinant. So I think it's clear. If you have any query, आप देख लो. वैल्यू इक्वल आ रहे हैं, वो नहीं हो सकता. मतलब इक्वल आ रहे हैं फिर तो कुछ मिला ही नहीं. क्या तो नेगेटिव आ रहे होते तो जीरो भी होता। जैसे पिछले क्वेश्चन में इससे पहले अगर a इज इक्वल टू a आ रहा है तो क्या मतलब है, कुछ भी नहीं हुआ। सॉल्व किया आपने इक्वेशंस दोनों, सब्ट्रैक्ट किया इसमें से इसको? नहीं, फिर कैसे? सब्ट्रैक्ट करो तो सही एक बार, सब्ट्रैक्टेड। अच्छा, p इज इक्वल टू q, p क्यूब इज इक्वल टू q क्यूब एंड p स्क्वायर q इज इक्वल टू q स्क्वायर p, सब्ट्रैक्टिंग फर्स्ट एंड सेकंड। करो चलो, नाउ स्टार्ट। दिस इज द फर्स्ट स्टेप यू कैन डू। सब्ट्रैक्ट करो, टेक आउट कॉमन और देखो फिर क्या लिखा भी है, p इज नॉट इक्वल टू q एंड देन c क्या बनेगा। कैंसिल आउट करने से पहले देख लेना कुछ भी। अगर आप जैसे मैंने यहाँ कैंसिल आउट किया तो इट इज गिवन कि डिटरमिनेंट इज नॉन जीरो, है ना, बिकॉज दो का प्रोडक्ट मैट्रिक्स है। इस बार हम अलजेब्रा नहीं पढ़ रहे हैं, मैट्रिक्स। तो इफ द प्रोडक्ट ऑफ दीज मैट्रिसेस इज जीरो तो फिर वो चार कंडीशंस आ जाती हैं। ये हो गया होगा आई गेस, तो मिटा देता हूं। subtract these two equations, subtract करो। p cube minus p square q is equal to q cube minus q square p, subtract it। क्या मिलेगा? what is the common value? p square, very good। p minus q and so you can write minus of p minus q, well you can write p square plus q square into p minus q is equal to null matrix, zero null matrix। समझ में आया ये? बिकॉज यू कैन राइट माइनस ऑफ पी माइनस क्यू, उसको उधर ले गए सो प्लस हो गया। ठीक है, समझ में आया ना ये? आई कैन एक्सप्लेन पी स्क्वायर इंटू पी माइनस क्यू प्लस क्यू स्क्वायर इंटू पी। अब तो सही है यहां से, अब ठीक है। टेकिंग आउट कॉमन पी माइनस क्यू तो यही मिलेगा आपको वापस। अब मैंने क्या बताया था आपको? दीज आर द टू मैट्रिसेस 3x3 3x3। टू मैट्रिसेस का प्रोडक्ट जीरो होता है, से स्क्वायर मैट्रिक्स। तो कौन कौन सी कंडीशंस आती हैं? टेल मी। चलो, पहली कंडीशन टेल मी क्या होता है? p स्क्वायर प्लस q स्क्वायर इज अ नल मैट्रिक्स एंड p माइनस q इज नॉट इक्वल टू जीरो। सो इट, हाँ, इट इज ए पॉसिबिलिटी बिकॉज p इज नॉट इक्वल टू q दिया भी हुआ है क्वेश्चन में। सो इट इज ए पॉसिबिलिटी, पहला। दूसरा, p स्क्वायर प्लस q स्क्वायर इज नॉट ए नल मैट्रिक्स but p minus q is a null matrix, it is not a possibility, ये नहीं होगा because p cannot be equal to q। समझ में आ रहा है? ऐसे सोचो कि दो का प्रोडक्ट नल मैट्रिक्स है, so either a is zero null matrix, b is not a null matrix, either a is a null matrix, b is not a null matrix। so a can be a null matrix but b is not a null matrix, so दूसरा केस तो वैसे रूल आउट होगा। थर्ड केस, दोनों नल मैट्रिक्स, वो ही नहीं सकता because p is not equal to q। and the last case, because it's a square matrix so they have to be singular। ab का डिटरमिनेंट अगर ab अगर प्रोडक्ट जीरो है, that means if they are not null matrices, that means उनका डिटरमिनेंट has to be zero। that means p स्क्वायर प्लस q स्क्वायर का डिटरमिनेंट भी जीरो होना चाहिए, as well as दोनों का साइमल्टेनियसली होना चाहिए, p माइनस q का डिटरमिनेंट भी जीरो होना चाहिए। you cannot break it in mod p minus mod q, वो नहीं तोड़ सकते इसको। अब बताओ, in both the cases, both the possibilities, what is the value of this? both the possibilities, इसको तो छोड़ ही दो। Answer is zero। take any possibility, answer is always zero। this was the question। JEE have asked this type of questions several times, in fact in advanced also and mains also। next question, this will be the last question, then we will start symmetric and skew symmetric based on the same concept, and you do and you see that, and I think this was the question asked last year in JEE। ठीक है ना, based on the same concept, तो इस बार ध्यान से करना। understood? जहां भी a into b जीरो आएगा, there are total 4 cases in case of square matrices। स्क्वायर में 4 केस बनेंगे, या तो ये नॉन जीरो ये जीरो, ये तो हो ही नहीं सकता, या फिर ये जीरो ये नॉन जीरो, माइट बी अ पॉसिबिलिटी, दोनों नॉन जीरो भी नहीं हो सकते। एंड द फोर्थ केस इज कि दे हैव टू बी सिंगुलर मैट्रिसेस। सिंगुलर के केस में और इस वाले केस में द डिटरमिनेंट इज जीरो इन बोथ द केसेस, सो यू कैन टेक एनी पॉसिबिलिटी, आंसर इज जीरो। Now see, one more question, then we'll start with symmetric and skew symmetric. See, let Mn be two 3 into 3 matrices. Same question. Mn be two 3 into 3 matrices such that Mn is equal to Nm. Mn जो है that is equal to Nm. Further, if M is not equal to N square, ये दिया हुआ है, वही सेम क्वेश्चन है, P Q 2 matrices है, कुछ conditions दे रखी है and P is not equal to वैसे ही कुछ है, and it's given that M square is equal to N की power 4. चलो मैं प्रूफ करने को देता हूं इस बार आपको. Prove that determinant of M square plus Mn square is 0. Same question, same concept asked last year in IIT. I think 2000, हाँ शायद 14 ही है, maybe 13 भी हो सकता है. So they just want to check the concepts, deep concepts basically, that you know or not. So Mn same, 3 by 3 square matrices. Mn is equal to Nm. M is not equal to N square, and M square is equal to N की power 4. So prove that the determinant is 0. Think twice before applying A square minus B square, because I've already told you A square minus B square is not equal to A plus B into A minus B. Not always equal to A plus B into A minus B. Algebraic identities directly नहीं लगेंगी, ठीक है? जैसे मैंने आपको बताया था A plus B into A minus B को आपको ऑर्डर वाइज ओपन करना पड़ेगा. किया था A plus B को A स्क्वायर फिर AB plus BA plus B स्क्वायर. तो प्लीज यहाँ पे A plus B A minus B अगर लगाओगे तो ओपन इट लाइक दैट. ठीक है, चलो करो. First find out कि A square minus B square की expansion how will you do in matrices? A square minus B square is equal to A plus B into A minus B. Open it and see what is expansion. A plus B into A minus B का क्या formula आएगा in case of matrices? Open it. Let's check होता क्या है. Is it A square minus B square or what? A plus B into A minus B is what? A square minus AB plus BA. Now see, is it is equal to A square minus B square, लेकिन if AB is equal to BA, otherwise this is the formula. apply the concept now. If AB is equal to BA, then only A plus B into A minus B is equal to, इसका मतलब याद रखो, algebraic identities will apply if AB is equal to BA. A plus B का whole square is also A square plus B square plus 2AB if AB is equal to BA. A plus B into A minus B is A square minus B square if AB is equal to BA. Otherwise, it's not equal. So how will you write the formula for m square minus n4 is equal to 0? A square minus B square को can you write A plus B into A minus B in this case? क्यों? Very good. Because mn is equal to nm. Now see, m square is equal to n4. This will give you m square minus n4 is equal to null matrix. हम इसे ब्रेक कर सकते हैं या नहीं कर सकते? चलो लेट्स सी, देखते हैं क्या होता है. Can I write m square plus n square into m square minus n square? Let's see, हम इसको ऐसे लिख सकते हैं या नहीं लिख सकते. Let's open it. इसको भूल जाओ. Let's open this thing. ठीक है, बताओ क्या आएगा. m square minus mn square plus n square m minus n4. ठीक है, तो देखते हैं ये सही है या नहीं है. m square minus m into n plus n into m minus n4. What is m into n? nm. तो nmn सही है. What is n into m? nmn. That means we can break this formula in terms of a square plus b, a plus b into a minus b, because यहाँ पे ये दोनों parts cancel out हो रहे हैं. Not because mn is equal to nm, because of this. Because nmn is equal to nmn. ये same आ रहे हैं दोनों, बराबर हो गए. ठीक है? तो if you want to apply the formula, be it a plus b into a minus b is equal to b square, वो तभी होगा जब ab ba के बराबर होगा. Or you can apply this, or you want to break this a minus b. If you want to break this, write down. If you want to break a square minus b square is equal to a plus b into a minus b, you can write if ab is equal to ba. So if you want to write m square is equal to n4 as m plus n square into m minus n square, is it because of mn is equal to nm? If it is not given, then this formula is wrong. You cannot break in this part. Do this. ठीक है? आप break नहीं कर सकते. So if mn is not equal to nm, you can't break it in these two parts. It is just because of mn is equal to nm you are breaking it, and this is the proof कि why we are breaking a square minus b square equality is equal to a plus b into a minus b. Just because if we open it like a matrix product, m square minus mn square plus n square m minus n की power 4, these two values are same because mn is equal to nm. ठीक है ना? That's why we are breaking it. I think now the question is very easy. Ab the product, we can write like this. Now a into b is 0. What does it imply? Those four cases. Same question up to same here. M plus n square is a null matrix, and this is not a null matrix, and it is a possibility because m is not equal to n square. So the first possibility is. So the first possibility is what? M plus n square into m minus, you can break, हमने कर लिया पता कि क्यों होगा break. Now the first possibility is m plus n square is a null matrix and m minus n square is not a null matrix. Might be a possibility because m is not equal to n square. दूसरा तीसरा case will rule out because m cannot be equal to n square. And last case हम सीधा कर लेते हैं. Fourth case जो है सीधा, वो क्या होगा? दोनों क्योंकि square matrices हैं, 3 by 3 is equal to 0 and m minus n square is equal to 0. In both the cases, determinant of m plus n square is 0. But हमें इसकी वैल्यू बतानी है, बता सकते हो? m कॉमन क्या आएगा? ब्रेक कर सकते हैं बिकॉज स्क्वायर मैट्रिसेस है, तो हमें इसकी वैल्यू पता है, किसकी? m plus n square की 0. That's why it's 0. So this is the rule. ये फंडा है. तो m square is equal to n की पावर 4 को a square minus b square we can write it because यहाँ पे we have proved it कि m square is equal to n4, ठीक है, because ये दोनों कट जाते हैं, तो we can write it like this, a plus b into a minus b. अब लिख लिया a plus b into a minus b 0. That means 4 possibilities, जिसमें 2 तो rule out हो जाएंगी. So first is this कि one is this null matrix, another is not a null matrix, and दूसरे में both are not null matrices but they are singular. So in both the cases m plus n square का determinant is 0, and in this case also if you take m common, so they have checked this property also कि if you know that we can break into 2 parts, mod a into mod b, so they have checked this property also. ठीक है. Now write down symmetric matrix and skew symmetric matrices. The next concept is symmetric matrices and skew symmetric matrices. So first write symmetric matrix. Understood ना ये concept? याद रखना ये चीज, कोई भी algebraic identity लगाने से पहले you have to think twice कि whether you can break it in like this or not. ठीक है, अगर break करना है तो first prove it, उसके बाद नहीं तो गलत हो जाएगा पूरा क्वेश्चन. And after that if you convert into 2 product कि a into b 0 and 4 cases, then देख लो कि कौन कौन से cases you can rule out and कौन कौन से cases you can choose. ठीक है. So next is symmetric matrix. क्या होता है? What is symmetric matrix? If the transpose of a matrix is equal to that matrix, is known as symmetric matrix. पहले we'll study everything about symmetric matrix. उसके बाद skew symmetric. ठीक है? The definition is कि if A is equal to A dash, then A is a symmetric matrix. That means symmetric matrices and skew symmetric matrices are type of square matrices. उसमें तो बाकी में तो नहीं हो पाएगा, because if they are not square matrices then definitely A cannot be equal to A dash, क्योंकि number of rows and columns change हो जाएंगी. 2 3 अगर 2:3 है तो 3:2 हो जाएगा, तो नहीं हो पाएगा same. So they are type of square matrices. They are types of square matrices. There are many types of square matrices, but today we will discuss only symmetric and skew symmetric. So A is equal to A dash. Example same way. A B C then D E then E. This is a symmetric matrix. ठीक है? So A is equal to A dash is the answer. If you interchange rows and columns, the matrix you will get is same. So that's a symmetric matrix. ठीक है ना? ABC BDE BDE CEF CEF. क्या हुआ? प्रॉब्लम नहीं? ठीक है? इसका मतलब ये हुआ, I can write it like this: AIJ is equal to AJI only if I is not equal to J. मैं AIJ को AJI के इक्वल लिख सकता हूँ. बाकी मतलब I equal to J के लिए तो खैर हो ही जाएगा same obviously, but I not equal to J के लिए AIJ is equal to AJI. मतलब अगर this is A12, so this is equal to A21. If this is A13, this is equal to A31. ठीक है ना? Second property. Second property में if A is a square matrix, then A plus A dash and A dash is always a symmetric matrix. If आप सुनो, A अगर स्क्वायर मैट्रिक्स है, नॉट सिमेट्रिक, इफ A is a square matrix, कोई भी स्क्वायर मैट्रिक्स ले लो, if you add a square matrix and its transpose, you will always get a symmetric matrix. And if you multiply A and A dash, you will also always get a. Let's prove it. देखो कैसे प्रूव करते हैं सिमेट्रिक है. A plus A dash का ट्रांसपोज अगर इसके बराबर आ जाएगा तो आई गेस हो जाएगा. है ना? मैंने बोला A plus A dash क्या होना चाहिए? सिमेट्रिक. A plus A dash सिमेट्रिक कब होगा? पूरा मैट्रिक्स जब उस मैट्रिक्स का ट्रांसपोज मस्ट बी इक्वल टू द मैट्रिक्स. ठीक है, हो जाएगा. A dash plus A is equal to A plus A dash, वही कम्यूटेटिव. इसका मतलब एग्जांपल भी ले लेते हैं. चलो 1 2 3 4 प्लस 1 2 3 4, सही है। दिस इज ए, दिस इज ए डैश, बताओ क्या मिलेगा? 2 5 5 8, सिमेट्रिक मैट्रिक्स। इसका मतलब ए कोई भी स्क्वायर मैट्रिक्स हो, इफ यू ऐड ए एंड ए डैश यू विल ऑलवेज गेट ए सिमेट्रिक मैट्रिक्स। इफ यू मल्टीप्लाई ए एंड ए डैश यू विल आल्सो गेट ए सिमेट्रिक मैट्रिक्स। इसका भी प्रूफ देख लो। ए डैश का डैश किसके बराबर होना चाहिए? ये हो जाएगा ना। ए बी का डैश क्या होता है? ए डैश का डैश ए डैश किसके बराबर आ गया? ए डैश। ऑलवेज सिमेट्रिक। If you want to prove any matrix is a symmetric matrix, just prove कि उस मैट्रिक्स का ट्रांसपोज इज इक्वल टू दैट मैट्रिक्स। ठीक है, बहुत सारे क्वेश्चंस आएंगे जिसमें यू हैव टू प्रूव कि यू हैव टू टेल कि वेदर दिस मैट्रिक्स इज सिमेट्रिक और नॉट। तो you just have to take transpose of that matrix, and that is, if it is coming out to be same matrix, that means it's a symmetric matrix. So if a plus a dash का transpose अगर इसके इक्वल आ रहा है a plus a dash के, that means it's a symmetric. If a dash का transpose अगर a dash के इक्वल आ रहा है दोबारा, that means a dash is a symmetric matrix. तो देख लो, b dash a dash होता है तो इसका dash क्या होगा? a, और इसका dash a dash, this is same, that means it's a symmetric. इसका मतलब if you multiply these two matrices also, तो क्या आएगा? सिमेट्रिक। देख लो क्या आएगा? 1 + 4 5, 3 + 8 11, 3 + 8 11, बस यहीं से प्रूव हो जाता है, डायगोनल से तो मतलब ही नहीं है। 9 + 16, सिमेट्रिक। तो कई बार हम ये सोच लेते हैं कि अच्छा ए सिमेट्रिक है तभी ये सिमेट्रिक होंगे, नहीं। ए इज एनी स्क्वायर मैट्रिक्स, देन दे आर ऑलवेज सिमेट्रिक। एडिशन एंड मल्टीप्लिकेशन ऑफ द मैट्रिक्स एंड इट्स ट्रांसपोज, वो हमेशा सिमेट्रिक देंगे। पढ़े आगे, देख लो इसको। क्वेश्चन नंबर 133, पेज। अच्छा अभी पहले ही कर लेते हैं, फिर करते हैं। ठीक है, हो गया। थर्ड, नाउ लेट्स स्टार्ट। इफ ए इज अ सिमेट्रिक मैट्रिक्स, अब देखते हैं क्या होता है। If A is a symmetric matrix, then A dash कैसा होगा? सिमेट्रिक ही होगा। If A is a symmetric, तो उसका ट्रांसपोज भी सिमेट्रिक, because both are same. माइनस A कैसा होगा? सबसे माइनस से मल्टीप्लाई हो जाएगा, सिमेट्रिक। के A कैसा होगा? सिमेट्रिक। ठीक है, तो if A is a symmetric matrix, then A dash minus A, K A, they are all symmetric. इसके बारे में क्या ख्याल है? B dash A B, ये कैसा मैट्रिक्स होगा? अब बताता हूं B क्या है। B is a square matrix of same order as that of A. ये कैसा मैट्रिक्स आएगा? ए सिमेट्रिक है और बी एक स्क्वायर मैट्रिक्स है, सेम ऑर्डर ऑफ ए। बताओ ये कैसा मैट्रिक्स आएगा? सिमेट्रिक और स्क्यू सिमेट्रिक में भी जो भी है, या कुछ भी नहीं, जस्ट सिंपल। चेक करने के लिए क्या करोगे? इसका ट्रांसपोज लेकर यू विल चेक कि वेदर इट्स कमिंग आउट टू बी माइनस ऑफ दिस और एग्जैक्टली इक्वल टू दिस और समथिंग एल्स। सी, बताओ, चेक वेदर दिस। सिमेट्रिक। लेट्स सी, बी डैश ए बी का ट्रांसपोज क्या आएगा? बी डैश ए डैश बी। व्हाट इज ए डैश? बिकॉज ए इज अ सिमेट्रिक, बी को तो कुछ नहीं है लेकिन ए सिमेट्रिक है। बी डैश ए बी सेम आ रहा है, लिख लो ये भी। it is also symmetric. साथ साथ लिख लो. If A is a symmetric matrix, A dash is also symmetric, minus A is also symmetric, KA is also symmetric. वो तो होगा ही कर, obviously you are multiplying a scalar, तो होगा ही symmetric. लेकिन B dash AB is also symmetric. ठीक है, where A तो है ही symmetric, B is a square matrix, just square matrix of same order as that of A. तो B dash AB अगर ऑब्जेक्टिव में आता है कि B dash AB बताओ, तो चेक करने का तरीका याद भी नहीं रखते अगर, तो the method to check कि आप ट्रांसपोज लो and just प्रूव किए दोनों इक्वल हैं, that means it's a symmetric matrix. Fourth, take two matrices now. Now if A and B are two symmetric matrices, if A and B are two symmetric matrices, tell me about AB plus BA. बोलो. अच्छा, एक चीज और लिख लो यहां पे ऊपर, A की पावर n is also symmetric. प्रूव हो जाएगा. A की पावर n मींस A into A का डैश इज इक्वल टू A dash A dash A dash, वो वापस A हो जाएगा. तो A की पावर n भी इंक्लूड कर लो इसमें. 1 2 3 4 5. A की पावर n is also symmetric if and n is either odd or even, it hardly matters n क्या है. So A की पावर n is always symmetric. Now if AB are two symmetric matrices, comment about AB plus BA. Symmetric पक्का. कैसे? AB plus BA का ट्रांसपोज क्या आएगा? A पहले एडिशन प्रॉपर्टी लगा लेते हैं, सही है. A plus B का ट्रांसपोज इज A ट्रांसपोज प्लस B ट्रांसपोज. फिर उल्टा कर लेते हैं, B dash A dash प्लस A dash B dash. What is B dash A dash? BA plus AB. BA plus AB, that means it's symmetric. लिख लो. This is also symmetric. Now comment for AB minus BA. आप बताओ. Same question. A and B are symmetric matrices. Now AB minus BA कैसा matrix हो? So its transpose is coming out to be same, or it's the negative of this? Negative. That means it's skew symmetric. लिख लो ये. C. AB minus BA का transpose is equal to AB, पहले subtraction property, हाँ, A dash minus B dash, उल्टा कर देते हैं, B dash A dash minus A dash B dash, BA minus AB, which is equal to minus of AB minus BA. That means AB minus BA ka transpose is minus of AB minus BA, and you all know that it's a skew symmetric matrix. So write down if AB and A and B are two symmetric, then AB plus BA is a symmetric and AB minus BA is skew symmetric. Third, what about AB then? What about AB? If A and B are two symmetric, then AB plus BA तो symmetric हो गया, AB minus BA skew symmetric हो गया. What about सिर्फ AB, only AB? It's a symmetric, skew symmetric, or depends, may or may not. Symmetric कैसे? AB का जो ट्रांसपोज है, that is equal to B dash A dash, which is equal to BA. AB को तो नहीं आया. If AB is equal to BA, then only AB is a symmetric matrix. लिख लो. If A and B are two symmetric matrices, then AB may or may not be symmetric. It depends कि if AB is equal to BA, तभी वो symmetric होगा. Otherwise, it is not symmetric. If AB is equal to BA, then only it is symmetric. If BA is equal to AB, then only AB dash is equal to AB. That means symmetric. ठीक है? Understood? So ये ऑब्जेक्टिव में आ सकते हैं कि if A and B are two symmetric, then A plus BA is symmetric, A minus AB minus BA is skew symmetric, जैसे ये A इज ए सिमेट्रिक तो B डैश AB इज ए सिमेट्रिक, तो याद अगर नहीं भी है तो यू कैन अप्लाई द प्रॉपर्टी, आप ट्रांसपोज लेके यू कैन चेक कि वेदर इट्स कमिंग आउट टू बी सेम और इट्स नेगेटिव और कुछ भी नहीं आ रहा, जैसे यहाँ पे है AB इज इक्वल टू B होगा तभी होगा, अदरवाइज इट्स नॉट पॉसिबल, ठीक है, राइट. स्क्यू सिमेट्रिक, some properties of skew symmetric matrices. बुक दे दो, कौन सी है वो बुक? ठीक है, राइट. स्क्यू सिमेट्रिक, skew symmetric first सबसे इंपॉर्टेंट A is equal to minus A dash, A is equal to minus A dash, इसका मतलब Aij is equal to minus Ji for I not equal to J. जो A है, अभी एग्जांपल दूंगा, जो A है वो ट्रांसपोज, बेसिकली ट्रांसपोज इज इक्वल टू नेगेटिव ऑफ A, ठीक है. सो Aij इज इक्वल टू माइनस Ji. इफ आई पुट I इज इक्वल टू J, Aii इज इक्वल टू माइनस Aii, दैट मींस Aii 0, सो Aii इज इक्वल टू, अब समझ में आया, the diagonal elements of a skew symmetric matrix are 0 because of this condition. 0 0 0. अगर ये 0 नहीं हुए तो डेफिनेटली A डैश का भी माइनस A के इक्वल नहीं हो सकता, वो तभी होगा जब ये तीनों 0 होंगे. लेट्स से यहाँ 5 है, यहाँ 6 है, तो यहाँ क्या आएगा? A11 इज इक्वल टू माइनस ऑफ A11. प्रॉपर्टी क्या है? Aij इज माइनस Aji, A11 इज इक्वल टू माइनस A11, तो A11 0, A22 0, A33 0, वो तो तभी हो पाएगा नेगेटिव. बाकी A12 इज नेगेटिव ऑफ माइनस A21, A13 इज माइनस A31, ऐसे यहाँ 7 है तो यहाँ दिस इज ए स्क्यू सिमेट्रिक मैट्रिक्स. डायगोनल एलिमेंट्स इसके हमेशा 0 होंगे, ट्रेस ऑफ ए मैट्रिक्स इसका हमेशा इट्स ऑलवेज 0. ये प्रूफ है इसका. You know A is equal to minus A dash, you know Aij is minus Ji, but if you put I is equal to J, that means Aii has to be 0. तभी A dash की वैल्यू माइनस A के इक्वल होगी अगर डायगोनल एलिमेंट 0 होंगे. अगर if they are not 0, definitely A dash cannot be equal to minus A. तो skew symmetric matrix की this is a major property. Second, now see, important property है यहाँ पे आगे जाने से पहले. Determinant of a skew symmetric matrix of odd order, हमारे कोर्स में सिर्फ 1 और 3 है, of odd order is always 0. लिख लो इसको. यानी कि 1/1 स्क्यू सिमेट्रिक में वो तो खैर 0 ही होगा. 3/3 स्क्यू सिमेट्रिक मैट्रिक्स का डिटरमिनेंट इज ऑलवेज 0, हमेशा 0 आता है. चेक कर लो, ये तो 0 हो ही गया. क्या आएगा बताओ? -5 के साथ कितना? 0, 42. आगे -+6 के साथ कितना आएगा? कितना आ रहा है? 35. कितना आएगा आंसर बताओ? 42 into 5 plus 35 into 6, 210. 210 0 आता है हमेशा, लेकिन सिर्फ ऑड ऑर्डर का. इसका मतलब ये हुआ कि इनवर्स ऑफ ए स्क्यू सिमेट्रिक मैट्रिक्स ऑफ ऑड ऑर्डर इज नॉट डिफाइंड. इसका डिटरमिनेंट ही 0 हो गया, जो सिंगुलर मैट्रिक्स हो गया, तो इनवर्स तो पॉसिबल नहीं है. तो इसका मतलब अगर आपको कोई बोलता है कि ये A है, फाइंड A इनवर्स, तो आप बोलोगे इट्स नॉट पॉसिबल बिकॉज़ इट्स स्क्यू सिमेट्रिक मैट्रिक्स ऑफ ऑड ऑर्डर, उसका डिटरमिनेंट 0 आएगा. आईआईटी वाले ये गलती कर चुके हैं. इन 2011 दे हैव गिवन ए मैट्रिक्स M जो ऑड ऑर्डर का स्क्यू सिमेट्रिक था एंड दे हैव आस्क्ड अ क्वेश्चन अबाउट इनवर्स, तो क्वेश्चन गलत हो गया था। इसलिए इसका इनवर्स इज नॉट पॉसिबल बिकॉज डिटरमिनेंट इज जीरो एंड इज ऑलवेज जीरो, हमेशा जीरो आएगा। यू टेक यहाँ पे a12 या a माइनस a12 या a13 माइनस a13, जब कैलकुलेट करोगे तो दे विल ऑल कैंसिल आउट, जीरो आएगा आंसर। व्हाट अबाउट इवन ऑर्डर? अच्छा, मेक ए स्क्यू सिमेट्रिक मैट्रिक्स ऑफ इवन ऑर्डर, कोई 2 by 2 का बना के दिखाओ स्क्यू सिमेट्रिक। If you will study higher maths, मतलब 4 by 4 मैट्रिक्स या सॉरी 5 by 5, तो you will always get determinant zero. Odd order का means 5, 7 सबके लिए जीरो है, but we will study till 3, तो इसलिए इवन ऑर्डर का बताओ। चलो इवन ऑर्डर कैसा होगा? Take any matrix of 2 by 2, क्या बनेगा? 0 0 2 minus 2, क्या रहा आंसर? अगर यहां a होगा तो यहां क्या आएगा? तो आंसर यू ऑलवेज गेट इज a स्क्वायर, इट्स अ परफेक्ट स्क्वायर। ये सब उसके लिए 4 by 4 के लिए, 6 by 6 के लिए। If it is a skew symmetric matrix of even order, it is always a perfect square, and if it is a of odd order, then the determinant is always zero. The first one is more important. ठीक है, तो इफ एनी क्वेश्चन कम्स कि भाई आपको बोला कि लेट्स से k वगैरह वगैरह, मतलब कुछ दिया हुआ है, लेट्स से 0 रूट k प्लस 1 0 0 माइनस रूट k प्लस 1 k स्क्वायर k माइनस k स्क्वायर, एंड बोला गया कि इसका डिटरमिनेंट बताओ, तो हाँ करने की जरूरत नहीं है, स्क्यू सिमेट्रिक तो आप जीरो करोगे, मतलब इररिस्पेक्टिव ऑफ द वैल्यू ऑफ k। ठीक है, थर्ड प्रॉपर्टी, हाँ जी, तीनों एलिमेंट्स ही जीरो होंगे। वो भी बाद में आएगा, उसमें जीरो आता है। ठीक है, बताता हूँ, देखो अभी वो बताऊंगा अभी बाद में, इसके बाद। ठीक है, थर्ड स्क्यू सिमेट्रिक में इफ A is a skew symmetric, if A is a skew symmetric, what about A dash? इसका ट्रांसपोज कैसा होगा? स्क्यू सिमेट्रिक। ठीक है, माइनस A स्क्यू सिमेट्रिक, k सिमेट्रिक कर देता हूं। नाउ a की पावर 2n, यहां पे फर्क पड़ेगा इवन और ऑड का। a की पावर 2, देखो दीज आर ऑल क्या? स्क्यू सिमेट्रिक, लिख लो, बट a की पावर 2n इज सिमेट्रिक। a की पावर 2n इज सिमेट्रिक। पता है क्यों? बहुत इजी प्रूफ है। a इंटू a अप टू 2n टाइम्स का ट्रांसपोज इज इक्वल टू a डैश अप टू 2n टाइम्स। a डैश इज इक्वल टू माइनस a 2n टाइम्स, ऑब्वियसली a की पावर 2n। दैट मींस वापस a की पावर 2n आ रहा है, इट्स अ सिमेट्रिक मैट्रिक्स, जस्ट बिकॉज -1 आपस में कलेक्ट हो गए इवन नंबर ऑफ टाइम्स, दैट्स व्हाई इट्स a की पावर 2n। सिमेट्रिक में फर्क नहीं पड़ता, इट्स इररिस्पेक्टिव ऑफ व्हाट द वैल्यू ऑफ n इज, आइदर इवन और ऑड, इट्स ऑलवेज सिमेट्रिक। बट if a is a skew symmetric, then a की पावर even power is always symmetric. What about odd power? Skew symmetric, लिख लो ये भी। a की पावर 2n plus 1 is always skew symmetric. a की पावर 2n plus 1 is skew symmetric. Then what about b dash ab? वही same question. If a is a skew symmetric, b is a square matrix of same order, ये भी क्या आएगा? बिकॉज ए डैश की जगह माइनस ए आ जाएगा. दिस इज स्क्यू सिमेट्रिक. तो A is a skew symmetric, then A dash minus A, K A all are skew symmetric, but A की part 2n is symmetric, A की part 2n plus 1 is skew symmetric, and B dash AB is also skew symmetric. अब दो पे आ जाते हैं. If A and B are two skew symmetric, तो फटाफट बता दो मुझे तीन क्वेश्चंस. AB plus BA, AB minus BA, and third AB. चलो, tell me whether they are symmetric, skew symmetric, or depends on the condition. A and B now are two skew symmetric. अब बताओ. हाँ. हाँ. But it's not in the course. Definitely we can find the conjugate of a matrix. There are two type of matrices, Hermitian and skew Hermitian, but I think they are not in JEE course or NCERT course. I guess I'm right, ma'am. Skew Hermitian and Hermitian are not there in the course. It's written वैसे. अच्छा, it's written here only, but I think it's not in our course. The course material for a JEE mains and JEE advanced, Hermitian and skew Hermitian conjugate. This is not in the course actually. वैसे we can find the conjugate. Rank of a matrix. This is also not in the course. Rank वगैरह ये सब. But फिर भी we can find, if you take the conjugate of all the elements, so we can find the conjugate. Because शुरू में I've already told you the entries of the matrices can be either real or imaginary. So if the entries are imaginary, so you can take the conjugate of each and every element. If 1 plus iota, then it will become 1 minus iota. हाँ ये आया. A plus AB plus BA is equal to AB minus BA and AB. तीनों का बताओ. इसका बताओ क्या आ रहा है. Symmetric. चलो let's see. AB plus BA transpose is equal to AB का transpose plus BA का transpose, यानी B dash A dash plus A dash B dash. This is minus B minus A, यानी BA plus AB. It's symmetric. This is symmetric. This is always skew symmetric. अच्छा, इसका मतलब ये हुआ कि if A and B are symmetric or skew symmetric, AB plus BA is always symmetric. And if A and B are symmetric or skew symmetric, AB minus BA is always skew symmetric. And I think AB it depends. It depends, ठीक है ना? It depends basically कि AB is equal to BA होगा तो ही होगा, नहीं तो नहीं. तो symmetric होगा फिर. If AB is equal to BA, then symmetric. बता दूं ये. Now your property was कि we can write any matrix as a sum of a skew symmetric and skew symmetric. अच्छा, one more property. जैसे मैंने बताया था, if A is a square matrix, so I told you A plus A dash and A dash क्या होगा, हमेशा symmetric होंगे. What about A minus A dash? Let's see. 0 0 sorry 1 2 3 4 minus A dash 1 2 3 4. पर A is a square matrix, simple. तो हमें पता है A plus A dash कैसा मैट्रिक्स आया था, सिमेट्रिक, एंड A dash कैसा आया था, सिमेट्रिक. A minus A dash देख लो क्या आएगा, 0 minus 1 1 0. सही, सिमेट्रिक. तो A plus A dash is a symmetric matrix and A minus A dash is a skew symmetric matrix. That means you can write any matrix A as a sum of symmetric and skew symmetric. Half of A plus A dash, ये symmetric, plus half of इसके जो एलिमेंट्स आएंगे देख लो 0 0 आएंगे यहाँ पे, है ना. तो A plus A dash symmetric plus skew symmetric is equal to A. This is the property of studied. क्वेश्चन लिख लो एक लास्ट. If let xy be 2 3/3 non-zero skew symmetric matrix and z be an 3/3 non-zero symmetric matrix. So you have to tell me कि which of the following are skew symmetric. Which of the following are skew symmetric? आपको बताना है, ठीक है? I will give you 3-4 options. Y cube Z4 minus Z4 Y cube, X44 plus Y44, X4 Z cube minus Z cube X4, and last option is X23 plus Y23. 23 मतलब. X and Y are skew symmetric and Z is a symmetric. 3 मैट्रिक्स हैं, 2 स्क्यू सिमेट्रिक, 1 सिमेट्रिक. आपको बताना है कौन कौन से स्क्यू सिमेट्रिक है. बेसिकली यू हैव टू फाइंड द ट्रांसपोज, कि ट्रांसपोज किसका किसके इक्वल आता है एंड किसका नेगेटिव आता है. कर दो फटाफट. फिर कौन सा? डिपेंड ऑन कौन सी कंडीशंस? व्हिच कंडीशंस? They are type of square matrices. Skew symmetric and symmetric are type of square matrices. And मतलब which type? Conditions means what? इसको बोलो थोड़ा सा explain करें. They are type of square matrices. कि if you interchange rows and columns, you will get the same matrix. So it's known as symmetric. And if you get aij is minus ji, it is a skew symmetric, and in which the diagonal elements are 0. I guess this is the concept. And if A is a symmetric matrix, तो ये symmetric होगा. If A is a skew symmetric, तो ये सारी चीजें skew symmetric होगी. If A and B are symmetric, तो AB plus BA symmetric होगा. AB minus B skew symmetric. These are the properties. तो I don't think कि conditions क्या होंगी. It depends on conditions का क्या मतलब है. अगर वो explain करें तो देख लो. है ना? हाँ. B and D. Anybody else? A and D. A and D. ये 4 है, ठीक है, 9 नहीं. This is 4. हाँ 4 है ये. 9 ले लिया था. This is 4A में. Y cube Z4 Y cube 4 दोनों 44 4 3 3 4 2 3 2 3. आया कुछ? हाँ? अच्छा इनका क्या बोल रहे हैं? अच्छा ए में मैंने आई हैव करेक्टेड. ए यहाँ पे 4 नहीं है 9 है. सॉरी 9 नहीं है 4 है. इट्स 4. अब आई थिंक शायद चेंज. ओनली डी. Karan, let's discuss फटाफट. See, first part is y cube z4 minus z4 y cube का ट्रांसपोज. क्या फॉर्मूला होता है? y cube z4 का ट्रांसपोज माइनस z4 y cube का ट्रांसपोज. यहाँ पे क्या आएगा? यहां पे एक तरह से ये है y y y z z z z का ट्रांसपोज क्या आएगा, z डैश z डैश z डैश z डैश y डैश y डैश y डैश। क्या वैल्यू आएगी इसकी, उसका भी ऐसे कर लेते हैं, माइनस क्या आएगा बोलो, यहां से यही लिख लेते हैं सीधा, y डैश y डैश y डैश और z आ गया, ठीक है ना, यही आएगा आई गेस। z कैसा मैट्रिक्स है, सिमेट्रिक, तो z की पावर 4, y कैसा मैट्रिक्स है, स्क्यू सिमेट्रिक यानी माइनस वाई क्यूब, y कैसा मैट्रिक्स है यानी माइनस वाई क्यूब, और ये कैसा मैट्रिक्स है, आंसर क्या आ गया, z4 y क्यूब माइनस z4 0। अरे मैंने गलत लिखा है, सॉरी 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 सॉरी, वाई क्यूब z4 माइनस z4 y क्यूब, सॉरी, ठीक है, तो डेट मींस ये तो सिमेट्रिक आ गया, तो पहला तो गलत हो गया, 9 की वजह से ठीक आ रहा था। चलो टेल मी अबाउट बी, सेकंड ऑप्शन, x44 प्लस y44, x44 प्लस y44 का ट्रांसपोज बोलो क्या आएगा, x44 का ट्रांसपोज प्लस y44 का ट्रांसपोज, यहां से आ जाएगा आपका कितना, x डैश अप टू 44 टाइम्स, और यहां भी आ जाएगा y डैश अप टू 44 टाइम्स। x डैश कितनी बार आएगा, क्यू सिमेट्रिक है, x की पावर 44 और y की पावर 40, ये तो वही हो गया, a की पावर 2n इज ऑलवेज अ सिमेट्रिक मैट्रिक्स, ये भी गलत हो गया, अंडरस्टूड। चलो तीसरे की बात करते हैं, तीसरे में क्या है, x4 z क्यूब का डैश माइनस z क्यूब x4 का ट्रांसपोज, ये हो जाएगा z डैश और ये x डैश हो जाएगा, सही है, और ये हो जाएगा x डैश और ये हो जाएगा z डैश, बताओ क्या आएगा z डैश, z कैसा था, सिमेट्रिक, तो z क्यूब ये क्या आएगा x4 माइनस ये कैसा आएगा x4 z क्यूब, सेम आ रहा है क्या, स्क्यू सिमेट्रिक, इसका नेगेटिव आ रहा है देख लो, नीचे वाले का थर्ड का है ना, सी इज द करेक्ट ऑप्शन, लास्ट है, ये सी ऑप्शन हो गया, समझ में आया सबको, ये देख लो ध्यान से देखो, ये हो गया z क्यूब, ये वापस माइनस एक्स माइनस एक्स माइनस एक्स माइनस एक्स, ये सारे माइनस एक्स और ये z क्यूब, तो एक दो इसका नेगेटिव आ रहे हैं, लास्ट रह गया x23 डैश प्लस y23, x डैश हाउ मेनी टाइम्स 23 टाइम्स, y डैश हाउ मेनी टाइम्स 23 टाइम्स, यानी कि माइनस x की पावर 23 माइनस सॉरी y की पावर 23, दैट मींस माइनस ऑफ x की पावर 23 प्लस y की पावर 23, C and D are the correct options. So they are symmetric and they are इस तरीके से करते हैं if you want to, ठीक है ना, हो गया, ठीक है, ओके, थैंक यू। अच्छा ये क्वेश्चन
today we discuss questions. So let's start off with problems on electric field, Coulomb's law, electric potential, potential energy, Gauss theorem. That is what I'm thinking. Chale, let's start with, okay, start off. Simple. You've done it, all of you? Module में? Clear? चलिए, let's go to the next question. ये आपने किया या सब सेंटर्स ने किया? सिर्फ आपने किया? तो एक बार दिखा दो फिर प्रीवियस क्वेश्चन. आ जाओ, कोई सॉल्व कर दो, आगे बोर्ड पे आ जाओ. कम. It says a charge is placed at each of the two opposite corners of a square. A charge Q is placed at each of the other two corners. If the resultant force on Q is 0, then what is the value of relation between small q and capital Q? So what you do is you find the net force on capital Q. इतना लिखने की जरूरत नहीं है. I mean, like directly आप लिख सकते हो. The value of F1 and F2 will be same. लिख दो. KQQ by A square. Q square by बस चलो. Okay, great. गलती करिए ना. You have to add vectorially. ये और ये दोनों का रिजल्टेंट यही लाई करेगा ना, तो उसको √2 से मल्टीप्लाई कर, है ना. परफेक्ट. Absolutely. Good job. Perfect. So we are done with this question. Let's take the next question now. Now, Coulomb's law for force between electric charges most closely resembles. So now the word is most closely, right? It resembles a lot of things. But how, when you say most closely, तो कौन सा होगा इसमें? By Coulomb's law is a inverse square law. Force, gravitation. So that is how you relate. So both are inverse square laws. Therefore, it is most closest to the law of gravitation. Simple question था. Third question देखते हैं. Great. Now this question relates to how you use or how do you find out the vector equation of forces. देखना. It says a charge Q1 is positioned at 2, -1, 3. This is the position of charge Q1. The electrostatic force on another charge Q2 at this coordinate, what would be the value of force on Q2 due to Q1? See, what also we have to understand is that it is, the answers are already given to you. सबसे पहले सॉल्व करना है. फास्टेस्ट सॉल्यूशन जिस स्टूडेंट का आएगा उसको बेनिफिट रहेगा. Now if you see all this very intelligently, this is 56, this is 56. This is 56 √4. मतलब ये दोनों कॉमन है. Magnitude wise both are common, and magnitude wise ये भी common है. The difference is in the unit vector. Now tell me, if I have a charge Q1 at 2, -1 and 3, and charge Q2 as the origin. Force मुझे किसके ऊपर निकालनी है? Q1 पे. Therefore, the unit vector will be pointing towards Q1 or Q2. Q2. अगर आप फोर्स यहां निकाल रहे हो, आप इसके कह रहे हो ना कि इसके वजह से यहां पर फोर्स कितना होगा. So that means your force will be directed along this vector. So that means it is pointing towards Q2. Now that means the unit vector should be along Q2. Now, Q2 means if I have to find a unit vector along Q2, it has to be 0 minus 2. Right? So it has to be minus 2i cap plus minus. जरा देखना क्या ऐसा तो नहीं है कि इनमें से कोई ऑप्शन डायरेक्टली दिखाई दे रही हो हमको ऐसी. तो कुछ सॉल्व करने की जरूरत है. No, absolutely. इस चीज का जरूर ध्यान रखो आप. When a question is given, please see the possible options also. Maybe you are not supposed to solve the entire question by reading the option. You can get closer to this. अब ये -2i यहां पर भी आ रहा है. Right? That means इन दोनों के बीच का जो गैप है, चार ऑप्शंस में से we are left with primarily two options. So any of these two options can be correct. अब ऑप्शंस का इस दोनों में से करेक्ट ऑप्शन कौन सा होगा वो कैसे डिसाइड करेंगे? द मैग्नीट्यूड, राइट? तो मैग्नीट्यूड कितना होता है? व्हाट इज द मैग्नीट्यूड ऑफ अ फोर्स? 1 अपॉन Q1 Q2. नाउ अगर ये वेक्टर फॉर्म में लिखा है तो व्हाट इज द वेक्टर फॉर्म ऑफ कूलम्स लॉ? R क्यूब इनटू वेक्टर. तो बेसिकली इस वेक्टर का मॉड लेना है मुझको और उसका क्यूब करना है. क्या हो रहा है? मॉड कितना आ रहा है? Which means what is the correct answer? D. So finally we get to know that D is the closest and the best possible option. Clear? Note करो इसको. मतलब question, एक है how do you solve a question? Understand how you should actually solve a problem. सवाल को सॉल्व करना तो सब लोग करेंगे, बट उसमें टाइम बहुत लगेगा. आपको ये देखना है कि शॉर्टेस्ट मेथड आपके लिए क्या हो सकता है. क्लियर? चलिए, लेट्स गो टू द नेक्स्ट क्वेश्चन नाउ. Right. Now, this question came in JEE 2014. One of the finest questions of electrostatics. Read the question carefully because this question relates electrostatics for the first time with surface tension. ये बहुत ही खूबसूरत सवाल है. जरा देखिए ध्यान से. What does it say? It says that there are 4-point charges. I'll help you. Fixed at 4 corners of a square planar soap bubble. Right? So generally when we think about a soap bubble, we always think it's spherical. But it's not necessary. Shape of a soap bubble can be anything. तो इसने कहा या soap bubble का जो क्रॉस सेक्शन है वो कुछ भी हो सकता है. तो ये कह रहा है कि ये स्क्वायर प्लेनर सोप बबल है जिसका साइड A है. There are 4 charges fixed at the 4 corners. The surface tension of the soap bubble is gamma. The system of charges and the planar film are in equilibrium. What is the relation between A, Q and gamma? N का वैल्यू क्या होना चाहिए इसके लिए? सोचिए जरा, थिंक अबाउट इट. सबसे पहले तो विजुअलाइज करो. ट्राई टू ड्रॉ द डायग्राम. डायग्राम बना के देखो. पहले बनाया? ओके. टेक योर टाइम. How do you like the question? कैसा लगा आपको? I told you earlier also, unlike mathematics, physics has to be first visualized. You have to first visualize this question and then understand that there are two forces involved. One is an electrostatic force and the other is a force of surface tension. अब दोनों की there is a property which both of them have. Like for example, electrostatic force always acts along the line joining the two charges. That's a fundamental property electrostatic forces have. One. Two, force of surface tension has to be tangential. Yes or no? होती है ना tangential and perpendicular to the surface in contact. You getting my point? आपको पता है surface tension कैसे दिखाते हैं? Anybody पढ़ा है आपने last year? Suppose मैं आपसे बोलूं कि ये एक liquid surface है, right? एक planar surface है ना ये square, एक plane ले लेता हूं. अब exactly हो क्या रहा है? That there are 4 charges. Q, 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 and Q. Tick. Suppose A. Now, B, we have to understand is that the force of surface tension will be applicable to a surface, not to a point. Tangential to the body, surface in contact, and perpendicular to the body. क्या मतलब है इसका? अगर मुझे force of surface tension ही कहीं दिखानी है, तो मुझे कोई एक surface identify करनी पड़ेगी. Yes or no? जैसे for example, class 11th में the first example which you did for surface tension was, आपको मैं remind कराता हूं, that there is a U tube, a U shaped, याद आ रहा है? Right, soap solution वाला. You have a U shaped wire. You keep a slider on the wire. You dip that wire in a soap solution, right? And what do you find out? क्या पता चलता है आपको? What happens? बोलो बोलो. What happens? Do you notice one thing? That if I keep that slider in a horizontal plane, I see slider moving in a way so that it reduces the surface area. यही होता ना? तो अगर मैं ये स्लाइडर को ऐसे मान लूं, if I were to assume that this is that U-shaped wire and this is a slider. अगर मैं इसको प्लेस करता हूं और सोप की फिल्म ऊपर और नीचे बनती है, दोनों जगह बनती है ना? How will this pen move? This way or this way? Towards right or towards left? This direction? Why? तभी इस surface area का minimum value आएगा. अब tell me one thing, ये slider, why does it move in this direction? Because therefore there should be a force which is acting perpendicular to this. कोई force ऐसे होगा तभी तो इसको अपनी तरफ खींचेगा. ये force कौन सी होती है? Force of. अब आप मुझे बताओ, अगर ये liquid का surface है और यहां 4 charges है, तो force of surface tension act कैसे करेगी? Yes or no? Now, what एक होता है property surface tension, एक होता है force of surface tension. What is the relation between them? अगर property of surface tension को मैं T से denote करूं, what is the value of force? जैसे इस केस में he has said, what does he say? The surface tension of a soap film is gamma. ये तो surface tension का value है, force का value कितना होगा? Into length. ये force पूरी length पर लग रही है ना? ये जो force है ये सब जगह एक साथ लग रहा है, right? That means what will be the force equal to? Gamma into. Yes or no? Now, what is the direction of force which this charge exerts on this? This. Yes or no? And this will be in this direction. ये वैल्यू कितना होगा बोलते रहो. Okay, by this will be, and this will be. ऐसे ही एक फोर्स यहां लगेगा, एक फोर्स यहां पर लग रहा होगा, and a similar force will act here. Yeah. Now what I'll do is I'll take इसका component इस direction में कितना होगा? What will be the value or the component of this force in this direction? 0. ये कितना angle है? So what would this be? K Q square into, yes or no? ये similar value यहां पर भी same value होगी. If I call it F net यहां पर भी इसी डायरेक्शन में होगा और इतना ही होगा. Yes or no? That means on this entire surface, what is the net force which is perpendicular to this planar body? This into, and what should that be equal to? That's all. आया समझ में? नहीं आया? लिखो. Have you understood the question? Or should I repeat it again? मैंने बताया आपको, let me repeat it again, that this is a film. The property of surface tension is to somehow reduce the area of this film. So by default, this will like to move here. ये नीचे आने की कोशिश करेगा, ये इधर जाएगा, ये इधर जाएगा. That means इस surface पर the force of surface tension will be gamma times A. Gamma is the surface tension, A is the length of the face. Now, इसको balance कौन करेगा? अगर इस system को equilibrium में रहना है, the system has to stay in equilibrium. That means there is a force towards right and there has to be a force towards left. तो हम क्या करेंगे? जो forces इन दोनों charges पे लग रही हैं, उनका resultant इस direction में जो भी होगा, वही इस force को balance करेगा. So that is the way you have to solve it. निकालना जरा n का value कितना आ रहा है? What is the value? कितना आ रहा है? Good. Yes, 3. 3 is the right answer. So it was a good question, isn't it? Right? Now, before I move on to the next question, some interesting facts, like for example, suppose I take this question, force of interaction between two charged elements. Like for example, I take a question that there is a circular ring where charge is uniformly distributed and the charge density, say, is lambda 1. Okay? ये रिंग इस प्लेन के परपेंडिकुलर रखा है. यहां पर मैंने I took one infinite line of charge. Charge density is lambda. 2. The radius of the ring is r. You get my point? Have you understood what I'm talking about? So I'm saying there's a ring, and on top of the ring, it's like this is a ring, and on top of the ring, I've placed an infinite conductor. Iska charge density lambda 2 hai. The charge density of this ring is lambda 1, and the radius is r. What will be the force of interaction between the two charged, between the two charges? I mean, we can ask you what is the force on the ring. We can ask you what is the force on line charge. How do you proceed? Acha, tell me one thing. First of all, tell me, what are you thinking? What is the direction in which you started thinking? चार्ज इस पर निकाला, वो तो निकाल ही लेंगे. चार्ज डेंसिटी इनटू इसमें क्या तीर चला लिया हमने. थॉट क्या है? हाउ विल आई कैलकुलेट फोर्स बिटवीन देम? आई हैव टू ऑप्शंस. ऑप्शन वन इज दिस अ रिंग. ये रिंग ही है ना, और ये मेरा वायर है. What I can do is I can find the value of electric field intensity due to the ring, say at a certain distance x. You know the formula? Electric field due to a ring on the axis, we know the formula. I can take a small element. I can calculate force on the small element, integrate it over the entire length, I'll get the value of force. Now this involves some steps, mathematical steps. But there is another way also. If I think the reverse way, अब मैं क्या करता हूं? Let me find out what is the value of electric field intensity on this ring. Now tell me one thing. As far as this length is concerned, I wish to calculate electric field intensity here and electric field intensity here. मुझे एक बात बताना आप, ये यही मतलब हो गया ना that I have to find the value of E here and I have to find the value of E here. Yes or no? The distance is R and this distance also R. ये हाँ है ना? बताएं जल्दी से. Yes or no? Right. Now, if I want to calculate the value of electric field intensity, this becomes a semi-infinite conductor. This length is infinite this side. So this becomes a semi-infinite conductor. Right? If I wish to calculate electric field intensity due to a semi-infinite conductor at this point, components कहाँ आएंगे? E ऐसे आएगा ना? So I'll have one component here. What is the value? K lambda by R. This is मालूम है ना ये तो? Infinite line of charge का वजह से what is the value of electric field intensity? 2K lambda by R. For a semi-infinite length, what is the value? K lambda by R. पक्का? Great. What about this point? ये कहां पर होगा? What will be the direction of electric field? ऊपर नीचे ऐसे होगा ना? तो एक यहां पर बोलते रहिए हाँ या ना. This is K lambda by R and this is, आपको एक इंटरेस्टिंग चीज दिखाई दे रही है? Both these components get. That means if I identify them as these 2 points, ये 2 points हुए ना? हाँ या ना? इसमें इलेक्ट्रिक फील्ड का वैल्यू यहां पर आएगा और एक यहां पर आएगा. ऐसे एक यहां पर आएगा, ऐसे यहां पर आएंगे. बोलिए हाँ या ना? वो सारे कंपोनेंट्स होंगे कितने? K, ये लैम्डा 2 लिया था ना हमने? K लैम्डा 2 भाई नहीं समझ में आई बात? भाई अगर मैं ये एक लाइन लेता हूं और मुझे यहां पर और यहां पर इलेक्ट्रिक फील्ड का वैल्यू निकालना है तो 2 कंपोनेंट्स होंगे ना, एक ये होगा और एक ये होगा. Similarly here the component will be like this and like this. Both these components will get and all the vertical components will get added. Net value कितना आएगा? यही आएगा ना? कितना आएगा इलेक्ट्रिक फील्ड का वैल्यू? K lambda 2 by R. And what is the charge on this length? If I replace this by 1 by 4 pi epsilon naught, R goes with R. So it's lambda 1, lambda 2 by, wow. This relation is independent of distance. This question can be asked in 2 ways. A, the force between them depends on 1 by R, R square, R to the power 0. B, it can be asked, is the force of interaction between them is constant or variable? It's constant. It does not depend on R. Yes, it does not depend on R. Or they could directly ask you, what is the value of force between them? Do you understand what I'm saying? So there were 2 ways to do it. I could have done it this way. Will take me a lot of time. I could have done it this way. Takes lesser time. Note करिए. Please ask your doubts. If you have questions, please raise them. We'll try to address them. Don't worry, we'll solve it before we go. समझ में आ गया ना? right? I'll take one or two similar questions on this pattern. एक सिचुएशन और देखते हैं. Suppose he says that there is an infinite line of charge. Say charge density is lambda 1. Are you all happy? Enjoy कर रहे हो? तो enjoy करने का मतलब smile होता है face पर. दुखी होने पर expressions होते हैं. और कुछ भी समझ में ना आ रहा हो तो ये होते हैं. 3 expressions. So कौन सा expression है? Believe me, you're blessed. Absolutely blessed. इस ट्रेनिंग को लेने के लिए you have absolutely no idea that how students travel from one place to another. I teach in an institute and I know how difficult it is to find Sandeep sir in a class. Sir, doubts कैसे होंगी? कहाँ questions होंगे? They keep struggling. And just imagine we are to us, we're coming to you. Yeah. So we want you to be happy at least and enjoy this process. ये आपको तभी समझ में आएगा जब आप इसको enjoy करोगे. And don't be in a conflict that I'm not able to solve myself. अच्छे questions हैं. They're topping questions. So it will not be easy for you to solve it on your own. So don't feel guilty. Don't feel that you're not able to solve them. Enjoy what's happening. Right? Just like next question देखते हैं. Next thought. There is an infinite line of charge. And what I've done is I've placed another charge in a plane perpendicular to this. Okay. And the charge density is lambda 2. And the distance between them is r. Can you find out the force of interaction between these two charged elements? Try करो. क्वेश्चन समझ में आ गया? यार ये एक दूसरा चार्ज एलिमेंट है. ऐसे एक चार्ज एलिमेंट तो ऐसे आ गया, ठीक है ना, बोर्ड के प्लेन पे रखा है. द सेकेंड चार्ज एलिमेंट इज प्लेस्ड परपेंडिकुलर टू द बोर्ड. आई विश टू कैलकुलेट द फोर्स बिटवीन देम and the distance between them is small r or capital R, whatever. मन से नहीं कर रहे हो, मन से करो, पूरी जान लगाओ. Give your best shot. Yes, this is the way she's thinking. Now, what do you know what she's doing? She says that this is one line charge. Sir कह रहे हैं ये second line charge है. आप जब तक ऐसे नहीं बनाओगे ये सवाल आपसे solve ही नहीं होगा. I'm asking you again and again. Visualize the question. I like this approach. Very fine girl. What's your name? Pratna. बहुत ही खूबसूरत नाम है. Very nice. Think like this. There's a line charge like this and there is another line charge. अच्छा. That means अब ये इसके ऊपर फोर्स लगाएगा. फोर्स तो हमेशा लाइन जॉइनिंग के अलॉन्ग ही होती है. अच्छा ये इनफाइनाइट लाइन ऑफ चार्ज है तो एक फोर्स ऐसे लगेगा. There'll be one force in this direction, yes or no? There'll be two components. There'll be two components which will add up. There are two components which cancel each other. And the question is done. That's it. करो करो करो. Come on, move fast. करके दिखाओ. Okay, tell me. कौन हेल्प करेगा? आप हेल्प करो मेरी. What's your name? Himani? Chal. What do I do? I'll take a small element here. I'll take a parallelly small element here also. Forces are vectors, so when we use symmetry, calculation becomes really, really simple. बताइए. What will be the direction? Himani, what is the direction of force between this and this? Yes. What is the direction of force here? Yes or no? Himani, if I take this angle as theta, and this angle also as theta, this distance is x, and this distance is dx. Similarly, x and dx. First of all, tell me what will be the value of electric field intensity due to this line charge at this point. It's an infinite line of charge. What is the value? By r कौन सा distance होगा? This distance. Yes. What will be this? Whole to the power? Oh, half. 2k lambda by r into what will be the charge of this element? Yes or no? बोलो क्या किया मैंने? Infinite line of charge की वजह से what will be the value of electric field intensity here? 2k lambda by r. R, you take this distance as r. What will be r equal to? X square plus r square whole to the power half. Into what will be the charge of this small element? What is the charge density? Lambda 1. So lambda 1 into, so that becomes the net force. Yes or no? So this is equal to force. Same force आएगी. Yes, Imani? अब क्या करूं? What am I supposed to do? Take the components. Which components will get it out of? ऊपर वाले, है ना? ये angle कितना है? So what is this? So what will be the net force? F net will be 2f cos theta. So it will be बोलते रहो 2 times 2k, yes, lambda 2 upon plus whole to the power into cos theta. And what is cos theta? R upon this. So can I remove this? And I need to, what will be the limits? X कहां से कहां vary कराएंगे? Suppose I take this length as L. तो लिमिट्स कहां से कहां तक लेंगे? अगर ये इनफाइनाइट है तो क्या लेंगे? कहां से लेंगे? माइनस इंफिनिटी टू इंफिनिटी और 0 to infinity? 0 to infinity. And why the reason? क्योंकि आप ये वाला पार्ट ऑलरेडी, भाई आपने जब यहां 2 ले लिया, when you already taken 2, so the limits, if it is infinite, it will be 0 to, and if it's for a finite length, it will be from 0 to L by 2. Yes or no? है ना भाई? तो अगर हम इनफाइनाइट कंडक्टर की बात कर रहे हैं तो फिर ये होगा F net का वैल्यू. Let's see. Girls, calculate it. Enjoy किया क्वेश्चन आपने? Yes, that is how you solve them. What is the answer? Huh? What is the answer? Lambda 1, lambda 2 by 2 epsilon naught. K को कर लो ना. 1 by 4 pi epsilon naught कर दो. Right? Replace K by. So what is the answer? Lambda 1. R भी आएगा. R नहीं आएगा. Yeah, could you solve it? Fantastic. That is the value of okay. Let's now think of a third situation. Possible third situation can be. अब imagine करते हैं that I have a semicircular arc. I don't have a complete ring. I have a semicircular arc. Say the charge density is lambda 1. Radius is capital R. इसके center से there is an infinite line of charge which is passing. And the charge density is lambda 2. What will be the force of interaction between these two charge elements? There is an infinite line of charge. Charge density is lambda 2. And there is in a perpendicular plane, there is a semicircular wire. And the charge density is lambda 1. And the radius is R. What will be the force of interaction between them? ये तूने गलत बनाया है. ये दोनों they are not in the same plane. They are not in the same plane. They are in a perpendicular plane, है ना? If this is a semicircular ring in this plane, this is the wire. Identify. See, सोचो एक रिंग बनाओ, half एक रिंग बनाओ अपने हाथ से बनाओ, right? ये semicircular ring है. ये हमारा लाइन चार्ज है. अब मेरे को फोर्स निकाला. आई हैव टू कैलकुलेट फोर्स ऑन दिस रिंग. अच्छा, अगर मैं यहां रखूं इसको, द फोर्स ऑन अ स्मॉल एलिमेंट विल बी इन दिस डायरेक्शन. द फोर्स ऑन अ सिमिलर एलिमेंट विल बी इन दिस डायरेक्शन. अगेन विल हैव टू कंपोनेंट्स. यस और नो? अब सोचो, थिंक अबाउट इट नाउ. Will those two components add up? There will be two components. Two will get added up, and two will get cancelled. Banao. Come on. Think. ये सिचुएशन यही नहीं है? बोलिए हाँ ना. Now, if you can visualize and draw this diagram, then things become very simple, isn't it? Now, what do I do? Now, what is the question in the previous question? In the previous question, this was a straight line. यही था ना? And this was a line charge inside the plane. In this case, this is not a linear charge. It is a linear charge distribution, but it is not a straight flat wire. It's a क्या करेंगे जी? क्या करते हैं? उधर x dx लेते हैं, इधर क्या लेंगे? If it is a linear conductor, you take x and dx. If it is circular, you take theta d theta. Instead of x dx, what do you take? Theta d theta. So let's do that. Yes. What will be the direction of force? बताइए. Yes or no? What will be the value of electric field intensity here? जल्दी से बताओ. 2 R 2K lambda 1 by R. What will be the charge on this element? This is d theta, na? R d theta into, boliye, yes or no? So if I multiply this with R d theta into lambda 2, this will give me the value of this force, yes or no? There will be two components which will get added up, and these two components will get, bolo hai na? If this is theta, if I've taken this as theta, what is this equal to? What is the value of F net का value कितना होगा बताइए? What will the value? 2 times. Can I take 2 times? Yes, बोलिए सब लोग. 2. Okay. R into and into cos theta. And I have to integrate this from was it difficult? No, it wasn't difficult. Because if you see in this question, I actually have to integrate cos theta d theta. बाकी सब constants है. अच्छा, by the way, what is the value of cos theta d theta of 0 to pi by 2? The integral of cos theta d theta 0 pi by 2 कितना होता है? आप वैसे कर रहे हो क्या पहले? cos थीटा का माइनस साइन थीटा, नहीं cos थीटा का साइन थीटा, और फिर उसको लिमिट्स डाल कैसे कर रहे हो? हे भगवान, क्या करें इनका भाई. इधर देखिए, अब एक चीज सिखाता हूं आपको. मैंने आई थिंक ओके, आई डिडंट टीच यू लास्ट ईयर. आई डिडंट टीच यू लास्ट ईयर, राइट? ओके, एक चीज देखो बड़ी इंटरेस्टिंग. क्या क्या बताना है? इंटीग्रेशन मीन्स फाइंडिंग आउट. कभी तो फिल इन द ब्लैंक से जवाब दे दिया करो. इंटीग्रेशन मीन्स फाइंडिंग आउट एरिया अंडर द कर्व. ग्राफ, कर्व बोलते हैं. ग्राफ बचपन में बोलते थे, 8th 9th में. अब वो कर्व बन जाता है. ठीक है, कैसे बनाते हैं साइन थीटा? ऐसे बोलो हाय ना. यस सर. ये कितना एंगल है? ये कितने खुशी खुशी से बता रहे हैं. कितनी बड़ी अचीवमेंट है ना भाई. गॉड, कमाल हो गया भाई. गॉड, माइंड ब्लोइंग. अब ध्यान रखना, सुनो. इसका वैल्यू +1 +1 -1 -1. So next time somebody says what is sin theta 0 pi by 2, it's 1. Somebody says what's the value of sin theta between pi and 3 pi by 2, it is, please याद कर लीजिए. Thank you. Cos का बता दूं आपको, ये लो. बोलो, हूं तो बोलते ना करो। हाँ, बड़ी खड़ी। अभी क्या निकालना था आपको? cos थीटा 0 to कितना होगा? वाओ, लाइफ बिकम्स सो सिंपल। क्या? हाँ, तुम करते हो ना पहले वो इंटीग्रेट करके, ये डायरेक्ट मेथड हो गया ना, मतलब इजीली यू कैन रिकलेक्ट। एक और बड़ा इंटरेस्टिंग चीज, एक रिलेशन होता है, पता है आपको कौन? सपोज आप इसको कैसे सॉल्व करते हो? cos स्क्वायर थीटा डी थीटा से 0 to π/2, तो इसमें तो पूरा जीवन लगा दोगे आप, 1 + cos 2 थीटा, फिर उसको इंटीग्रेट, फिर उसकी लिमिट्स, और डेफिनेटली सिली मिस्टेक जरूर कर देना। ऐसे करोगे ना? ऐसे करोगे? कुछ और भी तरीका आपके पास? बस यही जीवन में सीखा है आपने। चलिए अब थोड़ा जीवन को आगे बढ़ाते हैं। इसको देखिए, इसका भी कर्व बनाना सीख लीजिए। बाय द वे, cos स्क्वायर थीटा ग्राफ कैसा होगा? यस, प्रार्थना की बच्ची, ऐसे होगा ना? ये एंगल कितना? डांट क्यों रहे हो यार? ये कितना? ऐसे होता ना? क्या हुआ? तुम जो लिखवा रहे हो मैं तो वो लिख रहा हूं। अभी सोच लो, मिटा दूं? लो, क्या लिखूं? ये कितना होगा? ये पाई कैसे हो सकता है? हाँ, ये चलिए, ठीक है। इंटीग्रेशन cos स्क्वायर थीटा डी थीटा 0 to π/2, तो बेसिकली हमको एरिया अंडर दिस कर्व निकालना है ना, लिखना इसकी वैल्यू। वाओ, हाउ कूल इज दैट? आगे कभी आए, लिखो लिखो लिखो, इजी हो गया ना लाइफ? ये कुछ, देयर आर सम मैथमेटिकल ट्रिक्स व्हिच यू डेफिनेटली शुड नो. So we can actually have one class on this session also. I can give you mathematical tricks for all the formulae, which can help you actually in saving a lot of time in problem solving. I thought you did it last year, but we'll do it this year. एक क्लास सेशन ना इसी का रखेंगे, वो टका टक टका एकदम सब मेरे पास सारे, I have all these shortcuts. अच्छा, साइंस को थीटा ग्राफ कैसा होना चाहिए बाय द वे? Yes, π/4, 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 π/4. आगे से इंटीग्रेशन अगर कभी आए तो अब इसका कितना हो गया? व्हाट इज दिस वैल्यू इक्वल टू? इसको 1 बोलते हैं। बहुत खुशी की बात है। सो आंसर कितना हो गया? सॉल्व हो जाएगा अब? डन डन डन, आगे बढ़ू? क्या क्या कह रही है पागल सी? डन, आगे चले? कितना आंसर आ रहा है? व्हाट इज द वैल्यू? बोल प्रार्थना। के को 1/4 पे एप्सिलॉन नॉट डाल, लैम्डा 1, लैम्डा 2। तुम्हारी कैलकुलेशन स्पीड बहुत अच्छी है, आई एम वेरी इम्प्रेस्ड। बहुत अच्छा करती हो, थोड़ा सा सोचना और बेटर शुरू करो तो यू विल बी इन फर्स्ट 100, मार्क माय वर्ड्स। यू आर वेरी फाइन गर्ल, ठीक है? सो कैन आई रैप दिस ऑफ? चलिए आप थोड़ा डायग्राम वो देखते हैं यार, स्लाइड्स दिखाना। अब थोड़ा लाइफ को सिंपल करते हैं, थोड़ी कॉम्प्लिकेटेड सी होगी ना लाइफ, लेट्स मेक इट सिंपल। लाओ आओ, ये आप मतलब मजेदार क्वेश्चन, मेंस का क्वेश्चन है, फटाफट कर दो 30 सेकंड्स में। मैंने बताया था ना, व्हेन यू रीड द क्वेश्चन राइट इट साइमल्टेनियसली। बनाओ बनाओ फटाफट। क्या सिंपल है ना? Very simple question. What is the answer? No. R by 8. The correct option is C. आजा प्रार्थना. यहां पर कितने लोगों ने सॉल्व किया R by 8? आपने किया? चल तुम आओ फिर. इसको बुला लेते प्रार्थना. Come on, move. I'm not getting any answer from this group. Next question has to be yours. R by 8. So there's some question. Can I correct to that center? Done. Simple ना? Correct. Very good. That's the spirit. Chaliye. Let's go on to the next question. A particle of mass m and charge q starts moving from rest along electric straight line in electric field E equals E naught minus AX. A is a constant. X is the distance from the starting point. Find the distance traveled by the particle till the moment it comes to instantaneous rest. पार्टिकल रेस्ट पर तब आता है जब उसके ऊपर फोर्स जीरो होता है, या रेस्ट पर तब आता है जब उसका वेलोसिटी जीरो होता है. A particle comes to rest when the net force is zero or the net velocity is zero. क्या मतलब? बहुत डिफिकल्ट क्वेश्चन पूछा मैंने, तो आंसर करें प्लीज. Is the net force zero or the net velocity zero? Because when suppose I throw a ball up, when it reaches the highest point, what is the force acting on that particle? mg. I want you to respond, all of you. It is, but is the velocity zero? No. Yes, it is. That is why the particle comes back. So when we say a particle comes to rest, it means its velocity becomes. But is question में एक interesting part क्या है? That initially it is at rest. Already this particle was moving from rest So you want the particles to start from rest and finally come to rest. ये कैसे possible हो रहा होगा? Can you just analyze this question? Is there something in this question which tells you that yes, even from starting from rest, finally we can come to rest? कुछ है ऐसा? Acha, okay. Now, if a particle is at rest, how will it start moving? When there is a force. In this case, what will be the value of force? What is force? Electric field into charge. Electric field hai, charge hai. But do you see a very interesting part in electric field? It is E naught minus AX. That means when X was 0, what was the value? That will, it will start accelerating. Yes or no? As X increases, the value of electric field will, therefore it will start, there will be a time when the acceleration will become 0 and then the retardation will increase, and there will be a time when retardation starts. Yes, the right word is starts. Retardation starts and finally it comes to, पहले तो ये thought समझना है. First of all, we have to understand what is there, what is given in the question. Why is it, if it is at rest, why will it move? And if it starts moving, why will it come to rest? First to ye thought. Now how do you proceed? Proceed कैसे करेंगे? If you have force in terms of x or acceleration in terms of, मेरी तरफ देखो सब लोग. If you have force in terms of x or acceleration in terms of x, how do you relate it to velocity? What is the relation between acceleration and x? बहुत पिटाई हो जाएगी. क्या बोल रही हो? कैसी बातें? I'm not talking about time. I'm talking about x. How do you relate acceleration to v and x? V dv by dx. Yes or no? Lunch कुछ ज़्यादा हो गया क्या आज? हाँ? Come on, move fast. Yes, do it, do it. इतना सिंपल सा बात को इतना टाइम कैसे लग सकता है हमको? Do we understand this or not? Have we understood this? चलिए मूव करिए जल्दी फटाफट करके दिखाइए. Whoever gets the answer first, let me know. It's a very simple question, isn't it? प्रार्थना हो गया? इंटीग्रेट कर देना. dx को ऊपर ले जा. मुझे दिखा. अब इंटीग्रेट करो. x पहले 0, v बचपन में 0, x पूछ रहा है जब दोबारा 0 होगा तो ये तो पूरा 0 ही है. इसको इंटीग्रेट करो 0 बन. यस आगे ना. वेरी गुड. नाम बोलो जी. अंजुम. रेज योर हैंड अंजुम. कैमरा लाना यार अंजुम की तरफ. She becomes a star now. Whoever solves the question, the camera will focus on her. Anjum becomes a star. Anjum, raise your hand. Wow, Anjum has done this question. Now Anjum has to ensure that next question Anjum solve करेगी. जल्दी कर. क्या होगा? E निकाल जल्दी कर. हाँ जी. हाँ. तो एक्सेलरेशन क्या होता है? V dv by dx. हाँ. पागल हो गई क्या? V dv by dx होगा ना. तो हाँ तो कर देना. हाँ से क्या होता है? माथा पकड़ के बैठी है. बता मैं क्या करूं उसका जीवन में. जब देखो माथा पकड़ के बैठ जाती है. दिखा इतनी सारी बोतलें रखी हैं. आदमी चक्कर ही खा गिर जाए. क्या कर रही है माँ? जीवन नष्ट कर दो. भौंक मत दो. पहले फोर्स ले. E नॉट माइनस ax इंटू क्यू. फिर a लिख. E नॉट माइनस ax इंटू क्यू बाई m. इसको लिख v dv बाई dx. ये तो हमारे सारे खानदान को पता है. भौंकते रहते हो. ये नहीं कुछ बता भी दो. इंटू इंटीग्रेट. x 0 था. रेस्ट पर था. ये कहता है x पर दोबारा v कब 0 होगा. तो इसकी तो सेवाएं समाप्त हो गई. इसको इंटीग्रेट करके 0 के बराबर रखना है. तो मुंशी आप बता गई है भाई. हो गया. ग्रेट. वेरी इंप्रेसिव. ये हुई ना बात लड़कियों. और कम ऑन यार, तुमको करके दिखाना है. सब हमें नहीं पता. आज सारे क्वेश्चंस अंजुम ने फर्स्ट क्वेश्चन सॉल्व किया. शी बिकम्स अ स्टार. लेट्स सी हु इज द नेक्स्ट स्टार. नेक्स्ट क्वेश्चन. जो सबसे पहले करेगा द कैमरा विल कम ऑन दैट गर्ल. और जो लास्ट में करेगा उसके ऊपर भी कैमरा आएगा. चलिए सर दिखाए. नेक्स्ट क्वेश्चन प्लीज. एंड योर टाइम स्टार्ट्स नाउ. Charge Q given a displacement this, in electric field this, the work done is this. It cannot be more simpler than this. You cannot have a simpler question than this. Yes, come on, do it. तुम्हारा नाम क्या है? निशा. निशा करने वाली है. There is a fight between Anjum and Nisha. प्रार्थना भी चुप नहीं बैठेगी. Yes, Nisha has given the answer. A is the correct answer. Nisha, raise your hand. So Nisha is the next star. उधर देखो कैमरा पे. निशा उधर देख. Raise your hand. Yes, great, good job. Who's two? There's so many twos. Focus करो जी, focus करो. Great. If there is anybody in the other center who gets an answer, correct answer first, can immediately tell us that he or she has, no he, she's got an answer. He तो possible ही नहीं है. Express. Sixth question again. Sixth तो हमने किया है. Right. So, निशा आजा. अब तो मेरे चेले ही सॉल्व कर देंगे. यहां से जवाब नहीं आ रहे. Now this is the next term is yours. यहाँ प्रार्थना ने सारी पूरी चीजें संभाली हुई है. आप तीनों रिस्पॉन्ड करो. आप हेल्प हर. तो ठीक है, ये बेस्ट ग्रुप बन गए. अब 1 2 3 4 ग्रुप्स. विच ग्रुप, जो भी ग्रुप मैक्सिमम क्वेश्चंस आंसर करेगा will get a prize after this class. And the prize will be, I'll share my personal notes of the electrostatics with that batch, with that group. Okay? And the game starts now. नहीं, इससे पहले वाला, ये वाला नहीं, ये करना है. 6 करना है ना हमको. नहीं, हमें 6 करना है अभी. वो तो हो गया. हमें 6 पूछा, डाउट पूछा किसी ने. कर देना इसको, अभी जो किया था हमने, घबरा क्यों रही है? मैं हेल्प करूं? मैं करूं? ला मैं कर देता हूं। चलो, the entire class will help me in this question. अंजुम क्या लिखूं सबसे पहले? फोर्स, पूरा दिल्ली सेक्शन बोलेगा. ओके, नेक्स्ट. यस, अंजुम ठीक लिख रहा हूं? Limits. Limit comes again to rest. So the left hand side becomes equal to. So the whole thing, this becomes equal to. It's a simple integration, and we can solve it. Great. चलिए, एक इंटरेस्टिंग चीज आपको और बताता हूं मैं. Did we discuss conservative forces last time? किया था मैंने बताया था कि वो लाइन इन क्वेश्चंस कैसे करते हैं. मुझे कहने कुछ बता देना, मैंने लास्ट टाइम क्या कराया था. जस्ट मिनट. वो आई भी थी लास्ट टाइम. चुप ही हो जा. जीवन कुछ किया नहीं था क्या पिछली बार हमने? चलिए, I'll send you my personal notes. I'll email it to that center, to that person. I have developed an art called Think Without Ink in physics. Entire Iridov, entire Krotov, I have solved it in a minute or less than a minute. आप में से जो परफॉर्म करेगा वो पर्सनलाइज्ड सॉल्यूशंस आपके साथ शेयर करूंगा. तो यू वांट टू कुछ एक दो बच्चे इधर आना चाहते हो या द गेम इज ऑन? वांट टू शिफ्ट? इधर कोई हेल्प करना चाहते हो किसी की? तुम इधर मुंडी घुमा लो. योर मुंडीज गोज हियर. रोटेट. अब ये 3, ये टीम 3 हो गई. 4 अंजुम है तो अंजुम तो 2 के बराबर वैसे ही है ना भाई? चलो, एक बड़ा इंटरेस्टिंग थॉट आपसे शेयर करते हैं. Somebody said, sir, what do you mean by conservative forces? And electrostatic forces, are they conservative or non-conservative? तो मैंने उससे कहा, भाई conservative का मतलब ये होता है that they are path independent. He said, but how would I come to know that this particular force is path dependent or independent? या तो उसका नाम बताऊं मैं आपको. मैं बोलूं इलेक्ट्रिक फील्ड कंजर्वेटिव होती है, बट इफ आई हैव टू प्रूव दैट इलेक्ट्रिक फील्ड कंजर्वेटिव होती है तो फिर क्या करूंगा? देन व्हाट विल आई डू? सपोज आई टेक अ सिचुएशन दैट से इलेक्ट्रिक फील्ड इज एक्स आई कैप प्लस वाई जे कैप. किसी रीजन में इलेक्ट्रिक फील्ड का ये वैल्यू है, and he says that I have a charge of say 1 microcoulomb. I have to move this charge. This field has to move this charge, and I want to know whether this field is conservative or non-conservative. So uska best tarika kya hai? The best way is if I can find out the work done by this force and prove it that it does not depend on path, it will become conservative. Pakka? Now this electric field is in a plane, so the displacement of the particle will also be in the plane. So displacement vector लिखोगे क्या आप? In a plane, भाई R क्या होता है? Position vector. How do you write R as xi cap plus yj cap? So what will be the displacement vector? Dxi cap plus dy. If I wish to calculate work done, I need to take the dot product. क्या लिखोगे आप? E dot d. ये कितना आया जी? Now suppose, of course, into 1 into 10 to the power minus 6. Agreed? 10 to the power minus 6. ये निकाला मैंने total work done. Now suppose I want to prove that it is independent or dependent. So let me say that suppose the charge moves from 0, 0 to say 1, 1. तो अब क्या करेंगे? What would you do? You'll use an integration sign here. You'll use an integration sign here also. बोलिए हाय ना. x0 to 1, y0 to ये कितना आया? 0 to 1 plus 0 to into ये कितना आया? half plus half into 10 to the power. टोटल आंसर कितना आया? इस पूरे प्रोसेस में, इन दिस एंटायर प्रोसेस, I did not need or I didn't need the path. अब आपको सर हमें कैसे पता चला? शायद ले लियो आपने path. I'll explain how. Imagine a situation. ये क्लियर होगी बात? Imagine instead of this, my electric field was yi cap plus xj cap. If I follow the same process, क्या आएगा मेरा यहां पर? Y dx plus, yes or no, into 10 to the power minus 6. How can I write this? Yes or no? This goes with this. What am I left with? And what are the limits? कितना आ गया? I didn't need the path here also. अब देखना, ये क्लियर हुआ? समझ में आया मैंने क्या करा है? Can you integrate this function? Can you integrate y square dx? Is it possible? Can you integrate x dy? Is it possible? Not possible. If I tell you that x equals y, can you integrate it now? तो मैंने आपको ये दिया, तो you could integrate this and you could find the value of work done. ये देने का मतलब, if I give you the path, if I give you the equation of the path, you're able to find the work done. If I don't give you the equation of path, if I don't describe the path, you cannot calculate the work done. That means this is a non-conservative electric field. Without 2, this was a conservative. लिखिए इसको. Are you getting my point? So if you have to find out work done, and in finding out work done, you don't need the path. अपने आप function integrable हो रहा है. Everything is happening on its own. Perfectly fine. If you need the path, you need the expression relation between x and y, then in that case, their functions or those values are called non-conservative fields. Clear? Did you enjoy this? This is a very, very, very important concept. See, when you study forces, there are many ways to explain forces. Internal, external. Types of forces, electromagnetic, non-electromagnetic, gravitational, nuclear, weak, strong. But the most important way to describe a force is whether it has a conservative behavior or it has a non-conservative behavior. Like for example, friction, non-conservative. Electrostatic force, conservative. Now, when you study induced electric field, पढ़ा आपने अभी EMI पढ़ा आपने स्कूल में? When you study induced electric field in electromagnetic induction, non-conservative. So, एक पहचान, one way to identify whether a force is conservative or non-conservative is through mathematically. The second way to explain this is, अगर electric field conservative है, तो पूरे closed path में work done कितना होगा? And what is work done equal to? Change in kinetic energy. So if there is no work done, there is no change in kinetic energy. There is no change in speed. So अगर हमने कोई work done किया पूरे loop में, and after finding out the work done, doing the work, we find out that there is no change in speed. That means that work was conservative. That is the second way to identify a conservative and a non-conservative behavior. Great. So we move on to the next question. That is question number 8. Smiling Priyanka. Five vertices of a regular hexagon of side A, length L, RA, पहले किया है हमने. वाव, ये हमने पहले किया है. So A, B, C, D. Team A has already won this question. चलिए next question. ये सिंपल है ना? क्या पूछा सवाल में? क्या था? एक हेक्सागन है, उसमें एक चार्ज मिसिंग है, तो जो 5 फोर्सेस लगाएंगे वो वही होगी जो वो सिंगल चार्ज उसके ऊपर लगाएगा. ग्रेट. ओके, नेक्स्ट क्वेश्चन. The maximum electric field intensity on the ring of a uniformly charged ring axis of a uniformly charged ring, charge Q, radius R will be. मतलब if I have a ring on the axis, which point, at what point will the electric field intensity be maximum? आज आपको एक और शॉर्टकट बताऊंगा, मैक्सिमा मिनिमा निकालने वाला शॉर्टकट. आप कैसे करते हो जनरली? पहले सॉल्व करते हो ना. ये 2000 साल पहले तरीके खत्म हो चुके हैं. डिफरेंशिएट. चुप ही हो जाता हूं. ग्राफ बढ़िया है, ग्राफ बड़े ग्राफ बना रखे तुमने. Please explain question number 6. We have somebody says, hello sir, what if the center students answer first? Do we get the notes also? So we want KB sir, same here, please displace. जवाब दोगे प्रियंका? प्रियंका मैम से क्वेश्चन पूछते हैं. कर क्या रहे हो? बाय द वे, ये रिंग ऐसे बनेगी? इतनी गंदी रिंग, इसको देख के लगता ही नहीं सवाल सॉल्व करने का मन ही नहीं करेगा. ऐसे बनाएगी तो ये एक्सेस कैसे दिखाओगे आप? तो फिर ये देखो, ये भी ऐसे बना के मैडम जी क्या बात है, इनका लंच थोड़ा सा ठीक करो, दलिया वालिया शुरू करो इनका, खाना खा के सब सोते रहते हैं, बिल्कुल सब स्लीप मोड पे है। ब्रेन्स, स्लीपिंग ब्रेन्स, हाय 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 हाय, कैसे रिंग बना रखी है तुम लोगों ने, पता नहीं क्या रिसर्च करने लग जाते हैं यहाँ के बच्चे। एक्स भी आता है माँ, ऊपर आता है, फॉर्मूले याद नहीं है। अच्छा टेल मी फर्स्ट ऑफ ऑल, कल आपका क्लास फिजिक्स का हुआ था, सर ने डेरिवेशन कराया था, इलेक्ट्रिक फील्ड का डेरिवेशन बताओ। रिंग, what is the value of electric field intensity on the axis of a ring? जी बताएं। Tell me, if this distance is x, what is the value of electric field intensity at distance x? K Q x upon अब एग्जाम में दे विल नेवर आस्क यू द वैल्यू ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी. व्हाट दे कैन आस्क यू इज ए, दे कैन आस्क यू टू प्लॉट द कर्व, plot E versus X, or they can ask you like the way I asked you, where is the value of electric field intensity maximum. अब इस कर्व को ध्यान से देखिए, इस इक्वेशन को बड़े ध्यान से देखिए. Haven't you seen this equation 10,000 times in physics? मतलब फिजिक्स पढ़ी होगी तो, मतलब कंडीशन अप्लाइड, अगर फिजिक्स पढ़ा हो तो ये इक्वेशन बड़ी कॉमन सी इक्वेशन है, x अपॉन एक्स स्क्वायर प्लस आर स्क्वायर होल टू द पावर 3/2. पता है आपको? कई बार x नहीं होता, यही होता है, कई बार ये टू द पावर हाफ होता है, ये होता है ना सिचुएशन. नाउ दिस कर्व, इसका मुझे अगर कर्व बनाना हो, आई विल टेल यू हाउ यू कैन ड्रॉ इट. What will be the value of electric field intensity at x equals 0? 0. What will be the value of electric field intensity at x tending to infinity? 0. जब 1000 साल दूर चला जाएगा वो चार्ज रिंग से, तो on the right hand side, what will be the direction of electric field intensity? Towards right. And what will be the value of electric field intensity towards left? Towards left. Boli hai na? Wait, that's a positively charged ring. Yes or no? So if I take this direction as positive, this direction will become, I'm trying to teach you how to plot a curve without actually plotting it. How can you draw a curve for any equation by just following some basic rules? आप उस फंक्शन का वैल्यू एट एक्स इक्वल्स 0 चेक करो, आप उसका वैल्यू चेक करो एट एक्स इक्वल्स इंफिनिटी, then check the direction whether it is positive or negative. Yes or no? Now tell me one thing. There is a graph, Anjum, which starts from 0 and ends at 0. So it has to have a maxima. आप 0 से शुरू करके, if you end it at 0, there has to, from 0 it will rise, then fall, and then become equal to 0. Yes or no? Yes or no? Definitely it's a hyperbolic curve. हाँ है ना, टेंडिंग टू 0 तभी होता है ना फंक्शंस. Won't it start something like this? Now he's asking कि ये maximum value कब होती है. Now I'll tell you. whenever you have an expression like this, x upon x square plus r square whole to the power 3 by 2, one way is differentiate it, put it equal to 0, लेंदी हो जाता है, हाँ या ना? अगर आपको डायरेक्ट मेथड सिखाता हूं मैं, ये क्या है? एक्स स्क्वायर, ये क्या है? इस डिनोमिनेटर को बाहर लाओ, लिखो एक्स स्क्वायर इक्वल टू, ये जो आर स्क्वायर है ना, इसको 2 से डिवाइड कर दो, एक्स कितना आ गया? ठीक है? सपोज आप कहोगे सर ये तो आपको पता ही होगा क्योंकि ये तो होता ही है, तो आपने तो कर दिया ऐसे ही। सपोज यहां पर ये होता, तब आप क्या करते? बताइए लेडीज, एक्स कितना होता? हाउ ब्यूटिफुल, हाउ अमेजिंग। 4 होता तो मुझे बताने की जरूरत नहीं है। एक और सिचुएशन हो सकती है, क्या? ये होता ऐसे, आप क्या करते? आप 2 लो बाहर कॉमन, तो क्या हो जाएगा? 2 टू द पावर, ये हट गया, ये कहां आएगा? फिर वही कहानी शुरू कर दो, एक्स कितना होगा? मजा आ गया ना? लिखो, मैथमेटिक्स हो, फिजिक्स हो, केमिस्ट्री हो, whenever you have such an equation, you can directly use this method to solve problems. Understood this? कौन सा आंसर है? Which is the true answer? Fantastic. Good job done. पक्का ना? मजा आया? ये, did you understand what I taught you this? Use this to your advantage. You know, life is all about giving advantages to people. But you can only give advantages when you have the advantage with you. So become smart kids. Shortcuts, techniques, learn करो. Perfect. अब इसमें कुछ और आपको, अच्छा ये इसका सेकंड पार्ट ग्राफ कैसे बनेगा? Yes or no? जल्दी स्टूडेंट से करते सो क्रैम कर लेते हैं. Students have a tendency to cram graphs. You cannot cram physics. You cannot do it at all. Perfect. Completely understood. अब एक सिचुएशन और बताओ. 2 रिंग्स बनाओ. Make 2 parallel rings. यार उससे पहले ना मेरे को तुमको एक और क्वेश्चन कराना पड़ेगा. Okay, for example, let me teach you how to find null point. लिखो. This will be interesting. Multiple questions कैसे बन सकते हैं? Like for example, suppose there are two charges, plus q and minus 2q. ठीक है? And I ask you to plot. This is the x-axis. Plot electric field versus x graph. Can you plot that? Karna. Plot E versus X graph. I'm not saying electric field lines, electric field intensity vector as a function of X. Yes. How will you plot electric field intensity versus X graph? Two ways. One way, I take a distance X from one of the charges, find electric field intensity to that charge, then find electric field intensity due to the other charge, find the resultant, make the function. And then from the function, I draw the graph. ये करोगे ना आप? आप कोई ग्राफ कैसे बनाते हो? भाई आपके पास दो चार्जेस है. आप मान लेते सर एक डिस्टेंस x ले लेते हैं किसी एक चार्ज से. Now you take distance x, then you find electric field due to plus q. Then you find electric field due to minus 2q. ऐसे करोगे ना? Then you'll add them. You find a function. Once you have the function, then you would plot it accordingly. कोई और method भी है क्या? No, this is long. This is really, really long. But this is what generally is followed. But smart kids like you and students who are seriously into this zone of getting into IIT Advanced and getting into IITs, they have to be very smart. They should have a method which is definitely better than this method. What can that be? सीखेंगे आज आप? उससे भी तुमको आसान तरीका बताऊं? आप मुझे बात बताओ. I'll draw a line like this. I have to plot electric field intensity versus X. I'll take electric field intensity on the y-axis. X तो ऐसे ही रहेगा. बोली हाँ ना? Now what I'll do is I'll take a small. अच्छा, electric field is what? Force on a unit positive charge. +1 कूलम का चार्ज मुझे रखना है. मैं 3 लोकेशंस देखूंगा या 2 ही लोकेशन देखूंगा. एक, where my point charge is very close to this charge. 2, when my point charge is at infinity. जैसे if I place a positive test charge here, ये क्या करेगा इसको? Repellments towards left. ये क्या करेगा? कुछ नहीं करेगा. ये इसके इतने पास है कि इसका इफेक्ट इतना स्ट्रांग होगा कि इसका इफेक्ट प्रैक्टिकली दिखाई, ऑब्जर्व नहीं कर पाएंगे. यस और नो? पक्का ना? तो डायरेक्शन क्या होगा? टुवर्ड्स लेफ्ट. लेफ्ट यू टेकन एज नेगेटिव. तो इलेक्ट्रिक फील्ड इसके बहुत नजदीक कहां पर होगा? नेगेटिव. बोलो हाँ है ना? नेगेटिव. एंड द वैल्यू ऑफ इलेक्ट्रिक फील्ड इंटेंसिटी विल बी 0 और मैक्सिमम. Distance x is very, very small, so the value of electric field intensity will tend to infinity. Where do I show a negative infinity? Ye E, I am representing E here. So as I go up, the value of electric field intensity keeps, and as I go up, it tends to infinity. So I have to show कि इसके पास negative infinity है. कहां ले जाऊं? Absolutely right, girls. Yes or no? सब लोग जान लगाओ थोड़ी सी. अब एक पॉइंट चार्ज यहां पर लेता हूं. Now, if I keep a positive charge here, इसका इंपैक्ट ज्यादा होगा, इसका इंपैक्ट ज्यादा होगा, इसका ज्यादा. डायरेक्शन क्या होगी? टुवर्ड्स लेफ्ट, राइट. राइट इज पॉजिटिव. पॉजिटिव इंफिनिटी. कहां दिखाऊं? क्या बात है. अब इधर चलते हैं. Attraction, repulsion. Towards right, towards left. And right is tending to, I take it here. Attraction, repulsion. Towards tending to. When I go very, very far off, tending to infinity, this entire charge will look like one single charge. What is the total value of charge? Plus or minus? So if I place a test charge plus charge here, will this charge be attracted or repelled? Attraction is towards, and right is positive, tending to 0. 0 and positive. So where do I show 0 and a positive? 0 तो इधर ही होगा ना, और पॉजिटिव कहां होगा? ऊपर. करेक्ट टर्म. करेक्ट टर्म. इधर चलतम, इधर जातम. Positive charge. The whole thing will be attracted or repelled. Attraction is towards left, and left is negative. So negative 0. So where is negative 0? अब इनको मिलाने का समय आ गया है, इनको जोड़ने का समय आ गया है. तो आइए जोड़ते हैं. ये कहां पर है? ऊपर. ये कहां पर है? कुछ ऐसे होगा ना. ये किधर है? ये किधर? ऐसे होना, होना कि नहीं होना? They have to be hyperbolic curves. ये इधर होना, ये इधर होना. कैसे होना? अब पहले ऊपर जाना. It cannot go like this. Can it? जाना तो अपने को ऊपर है. कैसे करूं? ऊपर आना, फिर नीचे जाना. मजा आना, नहीं आना? ये समझ में नहीं आना? मैं बचपन में किधर होना? इधर. बाद में मुझे किधर जाना? इधर. मेरे को बताना कि मैं इधर से इधर कैसे जाए. कूद के जाएगा? नहीं जा सकता. कैसे जाएगा? हाइपरबोलिक कर्व पर जाएगा. कैसे जाएगा? ऊपर जाएगा. जाऊं? आए ना. एक मैक्सिमम आएगा, तभी तो 0 होएगा. यस और नो? ग्राफ बन गया आपका. बना लो. कम से कम 20 मिनट का क्वेश्चन है ये, 20 minutes question. If you have to actually find the function and then solve it, and it will take a lot of time. Enjoy the question and the solution. And if you have doubts, ask me. दोबारा बताओ, समझ में आ गया? अजूब आया क्या? नहीं आया कि नहीं? बता क्या? आ जा तू जरा, तू जो कहेगी ज्वाइन करता हूँ. आ जा बोर्ड पे आ. तो यहाँ बता क्या ज्वाइन कराऊं? एक पॉइंट इधर है, एक पॉइंट इधर है. हाइपरबोलिक फंक्शन बनाना है. कैसे ग्राफ बनेगा? ये प्लस मैक्सिमम है, प्लस इन्फिनिटी है. तो जो प्लस इन्फिनिटी से पहले मिनिमम वैल्यू आएगी तभी ऊपर जाएगा ना यार. तुझे इन दोनों पॉइंट्स को ज्वाइन करना है, सीधे लाइन से ज्वाइन नहीं करेगी. हाइपरबोलिक तो ऐसी फंक्शन बनेगा ना.
तो हम ये वाला क्यों कंसीडर कर रहे हैं, सिर्फ ये वाले क्यों नहीं कर रहे?
क्या वाले?
ये वाला और ये वाला क्यों नहीं कर रहे? ये वाला क्यों कर रहे साहब?
अरे तो सारे लेने पड़ेंगे ना यार. ये 3 रीजंस बन गए. एक रीजन ये, एक रीजन ये, एक रीजन ये. तीनों में फील्ड है ना, तो तीनों की फील्ड नहीं बनाओगे? हाँ. अब इसकी और प्रैक्टिस कराते हैं. कैसा लगा मेथड आपको? विद प्रैक्टिस यू विल इंप्रूव मोर एंड मोर. अभी कराता हूं आपको प्रैक्टिस. Perfect. Now, this helps you to achieve one more thing. In this question, if he says this is plus q and this is minus 2q, where is the null point? What do you mean by the null point? Electric field intensity is कहां पर है 0? ये graph, where is this graph cutting the x-axis? ये क्या हुआ? नोट करने का. Shut. Hello, no video. गोमती नगर. Are you clear? और देखते हैं. चलिए, now same question. I'll plot. Oh God. I'll plot potential versus x. या पहले प्रैक्टिस करें इलेक्ट्रिक फील्ड का ही, और प्रैक्टिस करते हैं. चलो, ये ठीक है. Let's take a negative, then we'll take a positive, then we'll take a, we have already taken positive, then we'll take 3 charges, then we'll take 4. Imagine करो 4 charge system, वो null point पूछ रहा है और हमारे उड़ान के बच्चे 10 सेकंड में सॉल्व कर रहे हैं. थोड़ा कॉन्फिडेंस रखो अपने ऊपर. चलिए स्टार्ट करिए. करेंगे स्टार्ट. चलो हेल्प करते हैं, मेरी हेल्प करने का. फर्स्ट ऑफ ऑल आई ड्रॉ. बोलो 2 लाइंस, यस और नो. स्टार्ट अप. यस, कौन बताएगा? When I place a attraction repulsion, left right is tending to, इधर बोलो, towards, left is negative is, चलो अब इधर चलते हैं. यस गर्ल्स, पॉजिटिव नेगेटिव अट्रैक्शन रिपल्शन, ऐसे स्टार्ट करते हैं. attraction is towards, right is, so यहां पर attraction, towards left. Left is total charge is negative. I place a positive charge. क्या होगा? Attraction is towards left, and left is -0. Positive charge here. Attraction, repulsion towards right. Right is positive. अब अंजुम जो आप कह रहे थे उसको ध्यान से देखिए. एक पॉइंट ये. I have to draw a hyperbolic curve. ऐसे नहीं आएगा ये. यहां पर हाँ है ना, और यहां पर yes or no. So where is the null point? आया मजा? चलिए एक और कर लेते हैं. अब एक काम करते हैं. Let's have more than 3 charges, 2 charges. Say plus 2q. Chalo, try to plot it. Done? Okay. G. Start off. Repulsion, attraction. Towards left. And left is negative. Perfect. Okay. फिर हाथ क्या इधर भी ले लेते हैं. Attraction, repulsion. ये चार्ज मैंने इन्फिनिटी पर लिया है, तो ये टोटल चार्ज नेगेटिव हो गया ना. विल इट अट्रैक्ट और रिपेल? अट्रैक्ट. द नेगेटिव चार्ज इज अ पॉजिटिव चार्ज. इट विल अट्रैक्ट. अट्रैक्शन इज टुवर्ड्स राइट. राइट इज पॉजिटिव. पॉजिटिव 0 कहां पर आएगा? परफेक्ट. इधर आओ. अट्रैक्शन, रिपल्शन. रिपल्शन. रिपल्शन मीन्स टुवर्ड्स राइट, and right is positive. इधर चलते हैं. Attraction towards right. फिर इधर चलते हैं. Towards यहां आएगा. Attraction towards right is attraction towards left. Left is जब बहुत दूर चले जाते हैं टोटल चार्ज नेगेटिव हो जाता है. This becomes a positive. This is a positive charge, so it will get attracted. Attraction is towards लेफ्ट एंड लेफ्ट इज नेगेटिव. अब देखो ये ठीक है. How many null points? This is null point 1. And this is null point 2. इलेक्ट्रिक फील्ड निकालने के लिए यू विल प्लेस अ पॉजिटिव चार्ज. तो ये क्या करेगा इस चार्ज को? अट्रैक्ट. हाँ, when you have to, how do you define electric field intensity? Force on a unit positive test charge. Clear? पक्का ना? चलो अब let's try to find out how do you, suppose they ask you plot electric potential versus the x graph. ठीक. फर्स्ट क्वेश्चन क्या लिया था हमने? चार्जेस कौन कौन से लिए थे? -2q. Now, two things. A, electric potential is scalar. So there is no towards left or towards right. Either it is positive or it is. Yeah, either electric potential will be positive if the charge is positive. Electric potential will be negative if the charge is number one. Number two, no vector addition. It's a scalar addition. Magnitudes को add करना है. And third thing, like electric field is 1 by r square, it's a hyperbolic function. Similarly, V is also 1 by r. Again, a hyperbolic function. So, जैसा इलेक्ट्रिक फील्ड का ग्राफ था वैसा ही पोटेंशियल का ग्राफ भी बनना चाहिए. बनेगा तो वैसे ही. चलिए स्टार्ट करते हैं. अब तो पॉजिटिव और नेगेटिव चार्ज रखने की जरूरत नहीं. यू डोंट हैव टू प्लेस अ पॉजिटिव और नेगेटिव चार्ज. इफ दिस चार्ज इज पॉजिटिव, अपनी विसिनिटी में टुवर्ड्स लेफ्ट एंड राइट पोटेंशियल पॉजिटिव प्रोड्यूस करेगा या नेगेटिव करेगा? टेंडिंग टू दोनों तरफ ऐसे ही रहेगा. इधर और 2000 साल दूर चले जाए इंफिनिटी पर, टोटल चार्ज नेगेटिव पॉजिटिव, पोटेंशियल विल बी नेगेटिव 0. और इधर भी नेगेटिव. आओ मिलाएं जीवन में प्रार्थना मैडम, टोटल चार्ज का कितना है? नेगेटिव. तो पोटेंशियल कितना होगा? परफेक्ट. अच्छा, यू कैन रिलेट व्हाट द नल पॉइंट जो आपने पहले निकाला था इसके साथ भी. कैसे? व्हाट इज इलेक्ट्रिक फील्ड? तो जहां पर स्लोप 0 होगा पोटेंशियल वर्सेस आर का, वहां पर इलेक्ट्रिक फील्ड. एंड देयर विल बी अ, so wherever the slope of potential versus distance graph is 0, electric field will be. And where is the slope 0? या क्या होना चाहिए? क्या होना चाहिए? null point. चेक करो, जब मैंने इलेक्ट्रिक फील्ड का ग्राफ बनाया था तो क्या null point यही आया था? यस यस यस, परफेक्ट. ये बात आया ना समझ में? अब पोटेंशियल समझ में आ गया। अब इसका एक दूसरा ग्राफ बना के देखते हैं। दूसरा हमने क्या लिया था, डिस्ट्रीब्यूशन क्या लिया था, व्हाट वाज द डिस्ट्रीब्यूशन, 3 वाला ले लेते हैं। क्या क्या था, +2q, चलो मचाओ। Somebody wants to ask a question क्या, किसी सेंटर को कनेक्ट कर दो। Somebody says explain V versus X graph. Okay, let me speak to Calicut. ये V वाला ग्राफ है ना, E होता है -dv/dx, जहां स्लोप 0 होगी वहां E 0 होगा। स्लोप कहाँ 0 होगी, स्लोप इधर 0 होती। अगर इफ आई ड्रॉ टेंजेंट हियर तो स्लोप कितना होती, तो यहाँ नल पॉइंट होती, यहाँ बिल्कुल नहीं होती, यहाँ V 0 होती, E 0 नहीं होती। क्लियर है, समझ में आ रहा है? वेरी गुड। So they say explain V versus X graph again. चलिए फिर मचाते हैं, let's मचाओ। Right, charge plus or minus, positive, so potential will be, and positive infinity, तो ये infinity positive positive। Okay, let's go very far off, total charges and potential will be, यहाँ पर charge is negative, so potential will be negative. Here the charge is negative, so the potential will be negative, and the potential here will also be. So this is so amazing. So it goes like this, right? It should go like this, goes like this. It's an approximate graph, by the way. It should go like this. Approximate shape goes like this. Slope किधर किधर 0 होती, तो इधर दोनों जगह नल पॉइंट होता कि नहीं, था कि नहीं, हो गया ना? That's it. ठीक है, अब मैं आपको एक क्वेश्चन, आई विल आस्क यू अ क्वेश्चन व्हिच इज ऑफ द एडवांस लेवल। ये वही कर पाएगा जिसका दिमाग चलता है, दौड़ता है। देखते हैं आप में से कौन इस क्वेश्चन को, दिस इज अ चैलेंज प्रॉब्लम। हो जाए, दो हाथ, सुन लिया मैंने, अभी तेरा के गला घोटता हूं। यही है ना, चले स्टार्ट करें. Brilliant question. 2 rings. ठीक है, and they are parallel to each other. Uniformly charged similar rings. सेंटर सेंटर कोइंसाइड कर रहे हैं. सेम चार्ज क्यू, सेम रेडियस आर. ठीक है, इनके बीच में जो डिस्टेंस है L, this distance is greater than 2r by root 2. The challenge problem. How many null points are there? Yes. How many null points? 1.
एक ये होगा, एक ये होगा और एक बीच में भी.
तो आ रहे ठीक से बनाएगी तो ठीक आ जाएंगे. बहुत अच्छा तरीका सोचा तुमने. बट
कितने से?
अच्छा, the best way to find null point is by drawing electric field lines. आपने वही तो सीखा भी. Not electric field lines, electric field intensity. इसका इलेक्ट्रिक फील्ड इंटेंसिटी ग्राफ कैसा बनेगा चेक करते हैं. इससे स्टार्ट होगा. बोलो हाय ना. ऐसे होगा ना भाई. इफ आई डोंट हैव द सेकंड रिंग, आई जस्ट हैव द फर्स्ट रिंग, दिस विल बी द ग्राफ. अभी तो बनाया आपने. रिंग का कैसे बनाते थे आप? ऐसे बनाते थे ना. और आप बोलते थे ये r/√2 पर मैक्सिमम वैल्यू आ रही है. ये लॉजिक था ना. ठीक है. अब जो दूसरा रिंग है वो इलेक्ट्रिक फील्ड कैसे प्रोड्यूस करेगा? जीरो से स्टार्ट होगा. इल्ले मैं बताती, ये समझ में आती. मैं इसको ना ब्रेड से बनाता हूं. प्रियंका क्या करती? क्या लिख के बोलता? Of course I can. Yes, I can. Yeah.
Sir, could you explain the previous question how when we are taking infinity, then how it became negative? Is it because the total charge is negative?
Yes. See, when you talk about potential, positive charge gives positive potential, negative charge gives negative potential. So when you're close to a positive charge, the potential will be positive. The effect of the second charge will be negligible. And positive means, and it will be tending to infinity. So you have an asymptote tending to infinity is, and positive means that you draw two small points tending to infinity on the y-axis. And when it is negative, you draw it downwards. You want me to draw it again for you? Dobara karu?
No, sir.
Perfect. How many students are there in Calicut?
8 students are, yeah, only 4%.
Acha, can I, what's your name?
Sister.
Sister. Wow. And how's the weather in Calicut?
It's fine, sir.
Fine. It's raining there in Calicut?
No. I mean, yes.
Sunny. Okay. Take care. ठीक है जी. आओ खेला जाए. क्या हुआ? खत्म कर दे क्लास, फिर बताता हूं तुझे. कहां से स्टार्ट करेंगे? कैसे जाऊं? कितना मजा आया कि नहीं? और हम कैसे लेंगे? आया? याद नहीं आया? रिंग का इलेक्ट्रिक फील्ड कैसे बनाते हैं अंशु? है ना? क्लियर? एब्सोल्युटली.
एक तो बीच में होगा ही होगा जहाँ पे दोनों का कैंसिल हो जाएगा. यहाँ पर आई तो इसकी वजह से तो जीरो होगा इस पॉइंट पे. यहाँ पर इसकी वजह से जीरो होगा, इसकी वजह से लगने वाला. और यहाँ पर मतलब यहाँ जीरो है, यहाँ पे इसकी वजह से लग रहा है. इस तरफ सिर्फ इसकी वजह से लगेगा. मतलब और जाएगा भी इंफिनिटी तक.
तीनों नल पॉइंट बीच में आ रहे हैं. पहली बात ये इंपॉर्टेंट है. नल पॉइंट इधर उधर नहीं है. तीनों नल पॉइंट्स in the best part about this is that all the three null points are between the two rings. है कि नहीं? चलिए. Great. अच्छा, स्लाइड्स पे लाना यार. Question number 9 is done. 10 ले लो. 10 करो. Okay, solve this question 10. It's a simple question. It says a charged particle Q mass m released from rest uniform electric field, gravity neglected, kinetic energy of the charged particle in time t seconds. How do you define kinetic energy, by the way? Net work done is change in kinetic energy. So what is the initial kinetic energy? 0. And he's wanting you to find out final kinetic energy. So what do you have to find out? Work done. What is work done? Force into displacement. B. Yeah. Absolutely. कैसे कर रहे हैं? I mean, we could have done it like this also. What is force is QE and displacement is half AT square and A is QE by M into T square. The correct answer is B. Next question. इसे next लाना. ये मैं करा चुका 13th. Try this. It's a good question. This has come in IIT-JEE. This came somewhere some years back. He says there are 3-point charges Q2, Q8, Q, and they are to be placed between a 9 centimeter long straight line. 9 centimeter के बीच में आपको इन तीनों को place करना है. अब वो पूछ रहा है आप place कैसे करेंगे? How would you place them? In such a way that the potential energy of the system is minimum. So how should you place the charges? In which order and where? In which order and where? Distance. किस distance पर? भाई दो charges तो 9 पर ही आएंगे extreme पर. जो third charge आएगा बीच में आएगा. तो point ये है कि जो extreme में charges हैं वो कौन कौन से होंगे और जो बीच में charge है वो कौन सा होगा और कहां होगा? So that the potential energy of the system is minimum. By the way, what is potential energy of a system of two charges? K Q1 Q2 by R. Let's be very simple. K Q1 Q2 by R. Now tell me, three charges, how do I place them? What should be the order? Potential energy minimum चाहिए. क्या करूं? आज किसका टेस्ट है तुम्हारा? अच्छा पूरा. कल क्या पढ़ा तुमने? फिजिक्स में. फिजिक्स न्यूमेरिकल्स की थे. हाँ. तुमने थियरी पढ़ाई थी न्यूमेरिकल्स? उन्होंने थियरी पढ़ाई थी. से पढ़ाया था? नहीं आया था। अच्छा, तू भी लिख अपना। तूने क्या लिखा? ये कह रही है 281, तुम क्या कह रही हो? क्या लॉजिक है? ये क्यों रखा? सुन रहा हूँ। तो पोटेंशियल एनर्जी होती है प्रोडक्ट ऑफ चार्जेस अपॉन डिस्टेंस। जितने बड़े वाले चार्जेस जितना दूर होंगे, मतलब प्रोडक्ट सबसे ज्यादा लेकिन डिस्टेंस भी सबसे ज्यादा, तो इफेक्ट कम आएगा। तो ठीक है, लेकिन वो दोनों चार्जेस बड़े वाले सबसे दूर होने चाहिए। Yes. So which group gives me the answer? Ajay, tell me first thing first is, you want potential energy to be minimum. Now, potential energy involves two things. One is product of charges, and the denominator is distance. I want numerator and denominator का कोई ऐसा रेशियो कि इसका वैल्यू लीस्ट आए। आर बड़ा और दर्शन छोटे नहीं, न्यूमरेटर छोटा। मैं इसको डिफरेंटली सोच रहा हूं। मैं सोच रहा हूं कि जितने बड़े चार्जेस हैं, द चार्जेस विच हैव द मैक्सिमम वैल्यू, इफ दे आर फारदेस्ट, पोटेंशियल एनर्जी विल बी लीस्ट। डू यू एग्री? आप जितने बड़े चार्जेस को जितना दूर कर दोगे, उतना ही सिस्टम का पोटेंशियल एनर्जी फॉल कर जाएगा। बोलिए हाँ ना, कम होगा। दैट मीन्स इफ आई कैन प्लेस 2q and 8q at extreme and place the third charge q somewhere in between, then the potential energy of the system will be least. Likhna. So place a 2q and 8q, right? So solve this question. Kar lena isko, because now we are ending this time slot. You have your test. So we'll discuss this question next time and some more questions next time. Thank you very, very much and enjoy your test.